Hello, welcome to Slooh and the latest in our decade-long run of live celestial broadcasts. Now, I hope you joined us a little over 14 hours ago for our live coverage of the Geminid meteor shower, one of the best we have seen for several years. Now, if you're a Slooh member, don't forget you can watch all of Slooh's archive of live celestial broadcasts over the last 10 years or so. But today, we have what I consider to be the most remarkable and awe-inspiring celestial event of 2020, the Great South American Solar Eclipse. Now, over the next few hours, the moon's shadow is going to race across the surface of the Earth, and we're going to watch the sun slowly being engulfed as the moon passes in front of it. And we'll learn a little later, total solar eclipses truly eclipse, excuse that, all other celestial events for their majesty and beauty. That there is just no comparison. I'm going to be talking a lot about that later in the show. But anyway, here at Slooh, we do this every day, where Slooh members watch the live views and control Slooh's huge telescopes at our two observatories. There's our flagship observatory at the Institute of Astrophysics at the Canary Islands and at the observatory of the Catholic University in Chile, who are actually providing one of our feeds today. Now, if you love space or astronomy, whatever your perspective, it doesn't have to be science, it can be art or culturally or any perspective you happen to like, you should join our global community of members to share the wonders of the night sky together. And if you know anyone else who might enjoy it, we have a great gift certificate on Amazon to surprise them with. That's a pretty cool prezi to get for Christmas. But anyway, now then, before we jump straight into today's glorious eclipse, I would like to share an adventure you can join us on in 2021. Now, over the last 10 years, I've been lucky enough to travel the globe to bring live celestial events to our millions and millions of viewers. We were the first to livecast these events to the public. And over the last decade, we've been to Kenya in 2013 for that ultra rare hybrid eclipse, if you remember that one, that brought me to absolute tears in the sandstorm. The Faroe Islands for the icy eclipse of 2015, the exotic Indonesian eclipse of 2016, and of course, our transcontinental eclipse expedition in 2017 for the North American eclipse, where we drove the mobile observatory, the Slooh Mobile Observatory, over the entire width of the USA. Plus, we always cover numerous other solar, lunar eclipses, near-Earth asteroids whizzing past Earth. They're always popular. Cataclysmic supernova explosions. They're pretty cool. And of course, stunning comets crossing the sky. But next year, here's the difference. You can join me on one of these adventures on the Slooh Antarctica Solar Eclipse Expedition. Wow, this is special. I tell you, it's a 20-day polar odyssey of exploration where we'll be among a small group of people fortunate enough to witness 2021's only total solar eclipse on December 4th. Now, we're going to talk more about the expedition and how you can join it near the end of the show. It really will be an experience of a lifetime when you hear about it. But hopefully, some of you will be able to join me and other members of our team on a glorious expedition. Oh, I'm so looking forward to that. Now then, let's get back to today's South American total solar eclipse and take our first look at some of the live feeds, if we've got any, because, oh, that's not looking good. Whoa, now I've been on calls with our observatory partners down there, the Pontificia Universidad Católica de Chile, basically the Catholic University in Chile. Now they are perched on the side of the most active volcano in Chile, but look at the weather. I can't believe how unlucky they've been. So they're on Volcan Villarrica, and they've been working for months to set this up for us. They're actually our partners for for Slooh's Chile Observatory, which gives us access, Slooh members, to the southern skies. Now, the whole, apparently, this is what we're hearing this morning, the whole of what's called the Path of Totality, this really narrow field of 56 miles wide, is where you can spot totality. in Chile is weathered out like this. So what we're waiting to see is whether or not we've got our Argentina feeds, which are going to come online a little bit later. Whether they've got, so we've got this great one here. This is from let me just tell you, the Parque Astronomica La Punta in Argentina. Now they've only got a partial eclipse there, but it's still going to be a pretty good feed by the looks of things. So we're looking forward to seeing that. But what we will do is we will cut back to our Chile feed on the volcano every now and again, because although they're in such dire weather conditions, we're still going to see a gradual darkening. And I'll tell you, with the cloud that they've got there, it is going to go pitch black at totality. So if the sky was clear there, in 6 minutes' time, that's when they would see the first little chunk of the moon take its bite out of the sun. And then they witness totality about 3 hours, 20 minutes' time, something like that. Now, when I spoke to them this morning, I said, do not ever give up hope, even under the poorest conditions, because we've been on some eclipse expeditions where we've had conditions like this, or we've been in the middle of a sandstorm in the heart of Africa, and moments, literally moments before totality, the clouds have parted and we've been able to witness the glorious event, which is totality. So anyway, right, we are going to hop over actually for an on-site report in a few minutes to hear from Daniela Fernandez, who's the resident astronomer at our observatory in Chile, and she's going to give us an on-site report, see what they're up to. Oh, are you there? I just heard a voice. No? Okay, I just heard a voice. Anyway, let's settle down to watch this spectacular event. Now, you can ask questions in Slooh chat if you're watching at slooh.com. And in fact, we already have one from Slooh member Carol Botha. And Carol's asking, at what speed does the eclipse shadow travel across the surface of the Earth? And does the speed differ at different latitudes? Well, the speed of the moon's dark umbral shadow does change as it's crossing the curved surface of the Earth. And at Volcan Villarica, it's traveling at a staggering 2,400 kilometers per hour. That's about 1,500 miles per hour in old money. Now, we'll take a look at the second part of that question when we talk about the Antarctica eclipse expedition. But here is Daniela. Daniela, hello, can you hear me?
Hi, can you hear me now?
Yes, we can. Hi, Daniela.
Oh,
It's not
I'm a,
looking good there. What's going on?
n- no, it's raining in all the path of the totality here in Chile. So we are not lucky today, but it will be a different, of course, eclipse.
Now, tell me very quickly then. You've been working on this for months now. And we've been talking all the time because we obviously partner at the observatory as well. When did you arrive there, and how long have you been working on setting this up? Oh, you're on our main feed as well. We can see you twice now.
Yes, I'm there. Hello. Well, we arrived 3 days ago and checked everything internet because we are in the volcano now. So it was really difficult to have really good internet in here. That was the first big thing that we have to do like 1 month ago. And we arrived here. The weather was every time like this. Yesterday we have sunny for some hours, but it was, as you say, it was months of work and everything to have everything prepared. But the south of Chile is like this, every time change, so we have to adapt and see what's happening in an hour more.
Well, I've just been saying to our viewers that you're still going to kind of witness the eclipse because it's going to start to get dark. And then around the
Yes,
time of totality, in an hour or so's time, a couple of hours' time, it's going to be pitch black there. So it's still going to be a very strange experience, I think.
I think so. So maybe we can talk late when, because we think that the of course the sky will be really black all of these
Mm.
clouds here. And then I will show you, of course, how the things are going on in here.
That's great. Thank you so much, Daniela. Daniela, by the way, I didn't introduce you properly when you just came on, but you're the resident astronomer at the Teaching Observatory of the Catholic University, which is where Slooh's telescopes are based as
Yes,
well. So I would just like to give you a public, huge thank you for helping us keep Slooh's telescopes in tip-top condition. And if you remember, it was only 1 year, almost to the day, where we installed, with the help of you, that enormous new Chile 2 telescope in the dome. That's a year ago. It
it was
seems
a
like a
year ago.
long
It was
time.
Yes, it was amazing, and the telescope is working really, really well. This month I was observing with Slooh for our students in Católica because our dome is not remote. So Slooh is a really good partner for us to teach childrens and also the people from students and in the Católica University. So thank you, you too, for this.
Wow.
All
Listen,
the team of Slooh.
well, thanks all around. It's the Mutual Appreciation Society. Daniela, we're going to let you get back inside into the warm and dry to continue your Spanish show. But we are going to see
Yeah,
you later on.
of
And we'd love
course.
to hear, we'd love to hear the experience that the team have had despite the clouds. And as I said to you on the phone the other day, don't give up until the very last second, because you never know. You never know
Of
if the
course.
clouds might part, although it doesn't quite look that hopeful. So Daniela, get in the warm and dry. Take care. Thank you.
Super. Bye bye. See you later.
That was Daniela Fernandez, resident astronomer at the Teaching Observatory of the Catholic University in Chile. And that's where Slooh has a huge 18-foot dome. And we have 3 telescopes in there, including this huge new telescope that we installed last year. And I have to say, from the moment that telescope went online, I don't think we've ever launched a new telescope that has been more popular with members. The stunning views that we've been getting of the Southern Hemisphere celestial gems. Oh my word, it's absolutely breathtaking. And we're in some. What I was about to say, we're about to hit summer in the Southern Hemisphere, but that view was not giving it. Now we're still waiting for our first view of the partial eclipse coming in from Argentina. Now, let me just take a look. I wonder if we could bring up the eclipse path diagram studio, because I'd like to, I want to explain why we're waiting for Argentina to come online. And right, so here we go. So here's a global map. Now the purple line in the middle, the kind of purpley blue one in the middle, that's the important one. That is this 56-mile wide path of totality. Now you have to be located within that narrow path to be able to witness totality. If you're in that larger green area, then you get to see a partial solar eclipse. But what happens is, a few hours ago, the moon's shadow first touched the surface of the Earth over there on the left-hand side at the end of the kind of purpley white line, right? And it's been racing across at 2,400 kilometers per hour and whizzing across the Pacific Ocean until it hit landfall on the west coast of Chile, as you can see. Now, there is the location of Daniela. And on the right of that, so we've got the Andes Mountains coming down. And then on the right of that, you see Argentina. So you can see that the shadow of the moon hits Argentina first and then travels across Argentina. And first of all, we get the penumbral shadow, which is when you start seeing a partial eclipse, and then when the umbral shadow comes over, that's when you see totality. And most of these locations are going to get about 1.5 to 2 minutes of totality as that umbral shadow moves over. But we're going to talk about that a little bit more later on. Now then, let me just catch up a second. Now, actually, I think we've got one more zoomed in view, haven't we, of Daniela's location here. There we go. And there's the volcano. That is the most active volcano in Chile, and they are perched on the side of it. There it is, and there you can see that umbral shadow, which was due to come over in a little over what is it, an hour or something like that. Yeah, no, in around 3 hours, 20 minutes time. So, anyway, right. It's not just Daniela that we've got on our show today, as well as hearing from Daniela a little bit later. I'm also going to be joined by Slooh astronomers Bob Berman and Mike Shaw throughout the show. And we're going to discuss everything there is to know about eclipses. And if you want to learn how to photograph a solar eclipse, maybe in Antarctica next year, if you join me on that Slooh expedition, or maybe even the 2024 USA eclipse, all right, there's no time like the present to start planning for these things. And Mike Shaw, astrophotographer extraordinaire, is going to tell us exactly how to do that. We are also going to be delving into this profound psychological effect that many observers, including myself, experience when witnessing a total solar eclipse with psychologist and eclipse chaser Dr. Kate Russo. This must be the first, because of COVID restrictions and travel restrictions, this must be the first eclipse that Kate's missed for many a years. We'll ask her about that a little bit later on. Now, don't forget, if you're watching the Star Party at slooh.com, you can snap images from our live stream, and we've got lots of people in the background working on that. So you can use those in our new solar eclipse quest that launched only moments ago. Now, if you don't know what a Slooh quest is, you'll learn all about eclipses and create your own personalized large format, and I mean large format, infographic poster that's going to showcase all of your best images that you snap from any of the live feeds we can conjure up today, hopefully from Argentina. Now then, what have we got? So we've, let me just catch up a little bit. We are going to take now a very short break. In fact, what we have got coming up is we're going to be explaining everything there is to know about solar eclipses with astronomy author Bob Berman. Bob, by the way, also narrates many of the live telescope feeds that members watch every night of nebulae, star clusters, galaxies, planets, the moon, the planets. Oh, we've got some special news coming about planets later. The Christmas star, that's going to be pretty awesome next week. And just about every other kind of object visible in the night sky. That's what Slooh members get up to every night. And in around an hour and 20 minutes, we'll see the volcano go dark. We're going to take a very short break, and after that, we'll welcome Bob Berman. See you in a bit. Hello and welcome back to Slooh's coverage of the Great South American Total Solar Eclipse, and I'm joined by astronomy author whose latest book, Zoom, is a great Christmas gift, by not Daniela Fernandez, it's Bob Berman. Hello, Bob.
Hi, Paul. Good to see you.
How are you this morning? You're up early for us, I understand.
Oh, yeah. That's great. Very exciting.
Now, here we go in Chile. The whole of the Path of Totality, which we'll explain a little bit later, Bob, in Chile, on the Chile side of the mountain range, is is totally washed out like this. But we are shortly going to be getting our first views from Argentina, I understand. But I wanted to ask you, Bob, you've been eclipse chasing for longer than probably you care to remember. This must be the first total solar eclipse that you've missed in a very long time, isn't it?
Well, it is, yes. Our tour company tends to be cowardly, and we avoid the ones with a low chance of seeing it. Yeah, unlike you, where you've gone to Africa, even though it was almost impossible to get there, you did it. I think you went to that eclipse off Iceland,
Yeah.
where the chances of clear weather were supposedly only a few percent. But we avoid those because we don't want to see people be disappointed. But you're right. Other than that, I've led 10 eclipse expeditions, starting back, I'll admit it, starting back in 1970. That's half a century.
Oh, oh. No, you're kidding. Gosh, 1970 doesn't feel like half a century. That's you've made me feel old now, Bob. Anyway, listen, let's for viewers, we haven't really talked about the absolute basics of solar eclipses yet. So, what is the phenomena that causes a total solar eclipse?
It's an astonishing either coincidence or divine plan, depending on your, background philosophies or religious beliefs. Because look at that. I mean, there are things in nature that some people say, "Oh, that must have been what a thing that the moon keeps the same side toward us. What are the chances that its rotation period and its revolution period are both exactly 27.32166 days?" But in truth, science looking at that sees no, it had to be that way. They're linked. One is tied to the other. We get the same situation with every moon of every planet. So, but this, Paul, is a case where there is no explanation. Why should it be that the sun is 400 times farther away from the moon and 400 times larger so that the two match? And we all know that. You look into the night sky by day or by night, and we only have two circles, two disks, the sun and the moon, and they both appear exactly the same size. So it's only because of that that you can have one perfectly fitting over the other.
It is such a wonderful cosmic coincidence, I always think. Now, we've got this diagram up, which is actually taken from the Slooh Solar Eclipse Quest, this learning activity that people do, snap their images and the live feeds that we'll have later on, and stick them into their poster here. So here we can see we've got two types of shadow here, Bob. We've got the umbral shadow and we've got the penumbral shadow. Now, I've already talked a little bit about that, but what's the difference between we've talked about this in the past. What's the difference if you're in that penumbral shadow, you see a partial solar eclipse, but if you're in that umbral shadow, you see a total solar eclipse? It's pretty good, isn't it, seeing a partial solar eclipse, which is 99.9% of the moon
Well,
covering the sun, isn't it?
is it just as good to almost fall in love? Is it good? Is it just as good to go to the tropics and there's the ocean and almost step into the ocean and feel that warm tropical water? No, it's a clear miss. It's one of those things that you'd think, even if it were 98% total, well, what's the difference between 98% and 100? That must be no, because this is one of those things, unlike a lunar eclipse where partial eclipse is just as good. It really is. I think a 98% lunar eclipse is just as
Yeah.
good as 100%. Not here. And that's because, as you well know, Paul, phenomena arise during totality and only during totality. If you miss it by even 1%, you don't see the corona, the sun's atmosphere. You don't see those pink flames leaping like geysers from the edge of the sun. And then there's that feeling that science hasn't really been able to explain that makes animals act up and people shout and scream and cry. They weep from it because it has an impact. You don't get that if it's a 98% eclipse. So for all these reasons, totality is the big deal.
It is. And I'm going to ask you in a sec to step through those phenomena that we can see uh, during and around totality. But I just wanted to point something out here, Bob. This eclipse diagram is quite unusual. We're a week away from December solstice, so we're a week away from the Earth's southern hemisphere, pointing, more to the sun than at any other time of the year. So it kind of the Earth looks a bit tipped back here, but we've got December solstice next week, and we're doing a live show for that, the still sun. And I just wanted to point out that that's why this diagram kind of looks a little bit odd in comparison to a lot of eclipse diagrams that we can see. Um, but what causes, surely in this diagram, we're saying there's the moon's orbit, it comes between the sun and the earth, causes a solar eclipse. Well, we know the moon orbits roughly once a month. Why don't we get a solar eclipse every month? Why are these
Yeah.
events so rare?
Yeah, that puzzles a lot of people. It's because the moon has about a 5-degree tilt to the Earth-Sun plane. And plane, we don't want to get fancy words here, but the solar system is rather like if you remember them, a vinyl record or a
I
CD,
remember them
a
well.
DVD. It's a flat plane. And if the moon's orbit were exactly on that same flat plane, we would get an eclipse every single month. Every time the moon came around, it would block out the sun. But that moon has a little bit of a tilt, only 5 degrees, but that's enough so that when you're actually looking towards the sun in the sky, if you could watch the moon at around new moon, which when it's closest, it normally passes above or below the sun. It misses it. So you need the a very rare phenomenon of the moon being new just as it's in the crossing place of that tilted plane, so that it's going from below the plane to above it or above it to below it. And those crossing places, those nodes, that's where the moon must be when it's new or pretty close to it, and that's what makes it rare.
And of course, we had the best meteor shower of the year last night, the Gemini's meteor shower. And here we are with a solar eclipse. So we know it's new moon today, which was great for the Gemini's meteor yesterday, because it meant that we had no moonlight to spoil the view. So we could see those faint Gemini meteors. We're still waiting for our live feeds to come up. It's going to be exciting when we see these coming up from Argentina, just as that path, that shadow, the moon shadow, is traveling across, racing across the Earth's surface over to Argentina. Now, Bob, so there we are. The moon's orbit is tilted, and we can see it in this diagram. So it doesn't always um, go directly between the Earth and the moon. But there's another factor that affects whether or not we see or what type of eclipse we see, because sometimes we don't have a total solar eclipse. And in fact, next year, we've got only one total solar eclipse at the end of the year, December 4th, where we're going on our lovely expedition. But earlier on in the year, there's something called an annular eclipse, a ring of fire eclipse. What is defining which one of those two things happen? Because you were talking about this cosmic coincidence. So why doesn't the moon always fully cover the sun?
Well, quite right. That's because the moon's orbit, as we see here, is not really circular, it's elliptical, and therefore the moon varies its distance from us. We know that with all the talk about supermoons, when the moon comes unusually
Mm,
close. But the moon can also be unusually far away. And it just so happens because that we want the perfect match, the moon to cover the sun, but not too much. We don't want it to block out those prominences, those flames coming out the edge, but we certainly don't want too little where the moon appears too small. That is, if it's farthest away in its orbit, it won't quite cover up the sun. And then we have, in essence, a type of partial eclipse, in that at best, we're left with a ring of fire, as you said, a circle of sunlight, which means you can't look at it. And it means that all those amazing phenomena that we love at totality, the
mm,
corona, the prominences, and a bunch of other things too that we haven't even mentioned yet, won't be seen. So an
mm,
annular eclipse is it fails to be a
yeah.
total eclipse. Yeah.
It's still, I'd still say that it ranks above a partial solar eclipse, because it is kind of quite wonderful to see just this ring of the sun left as this smaller moon is kind of inset over the top of it. But there's also, to show just how tight these margins are and just how close this cosmic coincidence and the math is, we also get a third type of eclipse. And this is what I witnessed down in Africa in 2013, and that's a hybrid eclipse. So what's that about, this third type
Oh,
of
yeah, that's
eclipse?
very
Well,
cool. So let's say it's a close call. The moon in its
mm,
orbit happens to be not near the nearest places in its orbit to us, so that it's big in the sky, the equivalent of a supermoon, nor is it at its very farthest where the shadow just won't reach us. The shadow tapers like a chopstick. It's narrower and narrower. So the question is, will it reach Earth? This is a perfect diagram for that, because you
mm,
can see here the shadow just barely reaches the spot of Earth. But now picture that you were on the part of Earth at the top or the bottom of this blue Earth image, near where the shadow line is.
yeah,
You could see that if you were there, the moon's shadow would not quite reach you. So, as the moon travels in its orbit at 2,288 miles an hour, that shadow, as it moves, it's possible for it to reach Earth just under it, let's say under the equator in this diagram, closest to where the moon is, and those people will see a total eclipse. But as that shadow moves, you'll reach a place on Earth that's still farther from the moon. So the shadow doesn't
mm,
quite reach there, and now it's only an annular eclipse in the same eclipse a few hours later. So some observers could see one, some would be the other, and that's a hybrid eclipse. Yes.
yeah. And I have to say, it was one of the best eclipses I've covered at Slooh. It was one of our first, and we had feeds set up on the west coast of Africa, which was further away, and they saw an annular eclipse there. But then the shadow, it was getting closer and closer, or the moon Earth distance was getting closer and closer because of the Earth um, curvature. And we in Kenya, we were at the cradle of mankind, Lake Titicaca, and we saw an absolutely wonderful total solar eclipse. But because of all of the math when the geometry was so narrow, we only saw 12 seconds, Bob, of totality. You were on that show with me, I recall now.
Yes, yes, and that's very typical, because from what we've been saying, it's obvious that if that shadow is going to just barely reach you, well, yeah, it barely reaches you, and so it sweeps. You're in that umbral shadow, that darkness, not very long. So it being only a few seconds long, but boy, do I give you credit. All the traveling you did, and the expense, and the inconveniences for 12 seconds
I
of
know.
totality. I'm sure people are wondering,
Yeah.
how could that possibly be worth it? But it was, wasn't it?
Wow, absolutely. Totality is always worth it. Can we just flick back to that previous graphic, the one that's showing the moon? Oh, there we go, Bob. We got our first live feed. This is, I think, coming in from Argentina, if the studio can confirm that in my logo. There we go. We've got the first sight of the sun being eclipsed by the moon. And there we can see, even with this little bite, Bob, we can see the curvature of the moon is identical to the curvature of the sun. So we can see this cosmic coincidence right in front of us here. Isn't that glorious?
It's glorious. And it brings up another coincidence, too, is that the moon's 2,160 miles in diameter. Its orbital speed, which I just mentioned, is 2,288 miles an hour. Now, look at how close those two numbers are to each other. 2,160 for its diameter, 2,288 for its orbital speed. And this tells you that the moon must move through space while it's orbiting Earth at one moon width per hour. No other celestial body does that. No, nothing moves at that speed of one of its own widths per hour. The
Mm,
moon is the only object in the universe. And because of that, as we watch now, we would expect it to take 1 hour from the time the moon first touched the sun, and we're just barely past that point now as we look at this great image.
mm.
And we would expect that it would be about an hour from now when
Yeah.
the moon is completely covering it. So it's lovely when things make sense, and it does
Wow.
in this case.
I'm just so glad we have finally managed to find a little pocket of cloudless sky. I can't believe, Bob. I mean, you talked about the amount of effort that we go to in the past to hunt down these amazing events. And I know that the Catholic University team have been working for months. We've been working with them. It's been an incredibly difficult one to set up. They got special permissions to be broadcasting live from the side of this volcano. Um, They've had to set up huge satellite dishes to be able to transmit Wi-Fi signals to a nearby town 10 miles away. So we've been doing all sorts of testing. By the way, we're using that equipment. That equipment's going to be transferred over to the Chilean University Observatory so that we can improve our signals there, by the way. But anyway, I feel so sorry for them to be wiped out as far as the weather. But as much as I'm enjoying this, I just very, very briefly, Bob, I want to hop back to that diagram where we saw a lunar eclipse marked up. Now, we often see a lunar eclipse either 2 weeks before or 2 weeks after a solar eclipse. What's the difference? This diagram is kind of painting 1,000 words, isn't it?
The question is, what's the difference?
Yeah, so what's causing a lunar eclipse versus the solar eclipse? We've got a lot of
Well,
people out there who don't know the difference between these two
yeah.
events.
Well, it's still shadow play. Notice that the lunar eclipse shown on the right, the moon is going to Earth shadow, and during a solar eclipse, the little piece of Earth is going into the moon's shadow. So in either case, it involves shadows blocking out objects. Solar eclipse, we see the moon blocking out the sun. But in a lunar eclipse, we're actually just seeing the moon going into Earth's shadow. We're not seeing anything blocking out a further object. We're just seeing the moon uh, lose its direct sunlight. And because there's
Mm.
actually quite a bit of sunlight that hits the moon indirectly, that is, refracts through Earth's thick atmosphere, and our atmosphere causes a reddening. The same thing that gives us our red sunsets or sunrises, that red light from the sun managing to go through the edges of the Earth where the atmosphere is and then hits the moon. So that's why the moon has this nice ruddy reddish appearance during totality. But it's quite nice even before totality. See, very, very
Mm.
different in that nothing really happens at totality. There's not a new phenomenon. With the solar eclipses, all these amazing things happen that we mentioned earlier. With a lunar eclipse, when it's total, there's not a sudden appearance of something new.
Yeah.
Really, it's just that the moon had been 99% blocked out of direct sunlight. Now it's completely blocked out of direct sunlight. That's it. Period. End of
And
story.
one of
Nothing more to
yeah,
it than that.
and one of the nice things, we often see what's called a blood moon during a total lunar eclipse. A lot of that is basically about representing the condition of our atmosphere. But let's move on then, Bob, to the total solar eclipse phenomena. We've mentioned a few of them, but let's step through them in order so viewers know what to keep an eye open for on any of our feeds that feature totality today. We've got something called Bailey's beads. We've got something called a diamond ring. You've mentioned the corona. What order do these knockout events take place in?
In chronological order or in terms of majesty?
In chronological order.
Okay. Well, the first thing at totality is if commonly as the moon is covering out that last bit of sunlight, there may be one last speck of sunlight shining through some lunar valley that's right at the edge of the moon's disk. And so you'll see one last little bit of direct sunlight, whereas the rest of it you'll only be seeing the much dimmer background glow of the sun's atmosphere, the corona. This really looks like a diamond ring. And that was first coined during the great New York City totality of January 24th, 1925. Some reporter in a New York newspaper called it a diamond ring. And that phrase stuck, and it's been used ever since.
Okay.
your question is really good as to what are the phenomena, because a few centuries ago, there's a wonderful essay in Slooh's book, The Saturn Above It. It
Yes.
presents a beautiful essay called The Eclipse, written by James Fenimore Cooper. I've reread that one. It's such a marvelous description of the early 19th century total eclipse that he saw near Cooperstown, where his family was from. But here's what struck me. Back then, they didn't know enough about the other things to look for them. To them, the corona that we're talking about now uh, was just like a little fuzzy glow around the sun when it was eclipsed. And
Mm,
because it was just like a little residual light, that wasn't even worth looking for to them. They didn't know that it's the sun's atmosphere and it shows the effect of the sun's magnetic field and that it has its own structure and that there are mysteries like why is it so hot and all the things that make us focus on the corona. No, to them, this is just like a little residual light. It wasn't worth looking for, and they don't mention it. And you can see in the essay, no one's
mm,
talking about, pointing out, or caring about the corona. Back then, what they cared about was the most obvious thing. Look how much dimmer everything looks around us in the
yeah.
countryside when this eclipse is going. And then the second thing they cared about is look what you could see the some stars in the sky. That's what they focused on, not us. We
So,
we we find that these phenomena are fantastic.
so for people who are lucky enough to either be in the Path of Totality today, or maybe joining us on the expedition next year, um, diamond ring is the first thing. So just at the moment, or just before the moment that the moon totally obscures the sun, we might get a single bead of light coming through and giving us that diamond ring. What's next that occurs? Is it Bailey's beads? Are they the next thing that we can see
No,
during
that
totality?
it's usually you get one or the other, Paul, because if it's in one of the we talked a little earlier about the moon's potential changing size during an eclipse, that it could be small or large. Well, if it's one of those eclipses where the moon just exactly or almost exactly matches the size of the sun, well, that's going to give you a short eclipse, but it's
Mm,
also may produce Bailey's beads because the fact that you're so well matched, you could get many spots of sunlight uh, sweeping around the edge of the moon because there's so much of that moon matching the edge of the sun's limb that you can get the effect of many diamond rings at once. So usually you'll get one or the other. You'll get the Bailey's beads phenomena or you'll get the diamond ring phenomena, depending upon how large the moon is and therefore how long the eclipse is. You can
Hey,
that's a
Bob,
good hint.
let me interrupt for 1 second. We've got another live feed coming in here, which is absolutely terrific. Now, before this disappears, we can see the white disk of the sun. We can see the moon starting to bite into it. So we know that this is over in Argentina because the eclipse only just started. But we saw some little wispy elements on the edge of the sun. Now, that is going to be superb news for us during totality. Can you tell us what they are and how they're going to appear at
Yes.
totality?
Yes, well, storms on the sun, which are essentially magnetic objects, they appear in places on the sun that happen to be 5,000 times more intensely magnetic than the rest of the sun. And these little local areas of magnetism constrict the material from inside the sun from rising as efficiently as it does on the rest. And the bottom line to all of this is you end up with material being able to escape from the sun's gaseous surface, the photosphere. It follow the beginning of magnetic field lines into space and produce these wonderful geysers of
Mm.
material. And these are coronal streamers or prominences. The small ones are prominences, and they're one of the most spectacular things you can see that you cannot normally see on the sun. And so we'll certainly be looking for these at totality. This is the
Mm.
time when you see them.
And this is where we're going to talk. By the way, after totality, a little bit later when you come on, we're going to talk more about the corona then. But let's look back in history. We've got Slooh's solar telescope. Here we go with the same feed with these prominences on the edge. You can see a big arched prominence at around the 10 o'clock position. At the 1 o'clock position, we've got a pillar prominence where we're probably just seeing it on its side. But we see a lot of these features in the Canary Islands, the Slooh Canary Islands solar telescope every day, as long as all the surface features, plages, active regions, filaments, sunspots, all manner of things. And I have to say the activity there has been quite extreme over the last couple of weeks. That's been building up quite nicely. But let's go back to our little story of what's happening at Totality, because you mentioned that observers can see stars and planets. It's an absolutely extraordinary moment, isn't it? Because it's as if somebody switches the light out, but then all of these other little lights come on. And so often we can see Mercury and Venus quite close to the sun because they always stay relatively close to the sun. It's a wonderful, unexpected bonus, isn't it, for a lot of totality observers for the first time, Bob?
Oh, it really is. You know, one is almost tempted to say the experience is ineffable, and that you try to
Mm,
tell people what you're feeling and how wondrous it is, and how it's like nothing else, and you really can't convey it with words. But that
mm,
said, when we look now today and just see the visual phenomena, we can't throw those feelings through the screen at people in their homes as they're watching this. But you certainly can get a hint of it by looking at the images, and it's very obvious that these are not ordinary life images. These are outside of normal human experience.
mm.
Because normally you don't see stars when the sun is shining, and you certainly don't see those geysers of flames leaping from the edge of the sun. And we haven't begun to speak of the mysteries or the details of the corona, which that's become
Yeah,
the big deal in the last, let's say, half century or so, unlike in
exactly.
previous centuries.
And with our modern telescopes, with these highly sophisticated solar filters and our space solar telescopes as well, where we can observe the corona and we can observe, a lot of these solar features, with quite a lot of ease. I say that a space telescope isn't really, that easy. But in the past, certainly in the 19th century and before, total solar eclipses were the only time scientists and astronomers could actually observe these solar phenomena. So, solar eclipses used to be incredibly important scientifically, didn't they?
They were, for those reasons, to study the sun, as you just mentioned, and also for other reasons as well. For example, it would be a time when you could triangulate the distance to the sun accurately, and the big hunt was for the scale of the solar system. Thanks to
Mm,
Kepler's laws, we had a relative notion of the size of the solar system. For example, Kepler showed us that Mercury must be zero point 0.4 times Earth's distance from the sun, and Venus zero point 0.7, and Jupiter 5.2, and Saturn 9.5. And so we knew, but what does that mean in terms of real miles? Okay, so Venus is zero point 0.7 times our distance, but what is our distance? Our distance was called the astronomical unit. But what's the value of it in miles or kilometers? We didn't know. And a total eclipse gave us an opportunity, observe from a few locations, could let people triangulate directly through trigonometric parallax and find the value of the astronomical unit. So going back a century and two, that was one of the big deals of solar totality, above and beyond learning about the sun itself.
wow. Now, Bob, before you leave us, you're going to come back later. But once again, for people on the ground in Argentina, unfortunately, Chile, anybody there in Chile is looking at clouds at the moment, but in Argentina, they've got clear skies. Anybody within that path of totality? Oh, there's the latest view from Chile's most active volcano. That doesn't look. In fact, can we see it? can't really see it darkening that much, but they will certainly go into absolute darkness at totality. But what I wanted to do, Bob, is just briefly ask you, for people who are on the ground, able to witness this themselves, I always say and remind people that before totality, a lot of the best stuff to do with a solar eclipse is actually happening behind you. So some of those observers should be looking behind them, shouldn't they? And a lot of that has to do with the kind of shadows that they can see. What should people be looking out for who are in the path of totality today?
Well, it's true. One of the things was that the size of the sun seems to change as it gets smaller and smaller. And many people don't notice this in everyday life, but the nature of your shadow depends on the size of the light source. So that we're used to this because the two main shadows we see in nature, that of the sun and those cast by the moon, because the two are the same size, they look identical. So look behind you today if it's a sunny day when you're outside, and you'll see that the shadow that you cast has a little bit of a blurry edge to it,
Mm,
especially the shadow of your head. The closer the shadow is to where it's hitting, let's say the shadow of your ankles or your knees on the ground, you'll see that those are quite a bit sharper, but not
mm,
still razor sharp. But the shadow of your head is always blurry, and it has nothing to do with how late you stayed out and what you did last night. It's really the size of the sun casting it, but not at totality, because as
mm,
you approach total before totality, even when there's only a little bit of sun left, the sun has been reduced to a small object in the sky. And that makes your shadow and the shadow of everything around you so sharp and strange and well defined. Plus, the light is now reaching you only from the edge of the sun, the limb of the sun. And this
mm.
produces its own effects. And so, all in all, as you look around you, we're not even talking about how amazing the sun is to look at. We're talking about the countryside, as you've just
Yeah.
mentioned, around you, your shadow and that of everything else. Everything is more highly contrasted. The shadows are stark. There is even a polarized effect, and everything looks unworldly. It's like
Worldly, it
uh,
is.
you're on a different planet, bathed by the light of a different kind of star than our own sun, and it's quite marvelous.
It is, and I think you've just come up with the word I've been searching for years. It is unworldly because I've been trying to explain. We're going to talk to Dr. Kate Russo, psychologist, about this a little bit later. Experiences these eclipses when you're there under those skies. You know that something's wrong. You know that something's alien. It's different, but you can't put your finger on it. And you see this in animal behavior as well. A lot of animals start, going a little bit wild as much as going to sleep during actual totality and then wake up a few seconds later or whatever. But it is an unworldly experience, and I think that's what actually drives my emotion when I
Okay.
witness this. We must talk more about that, Bob, when you join us a little bit later. But thank you very much for
My,
now. We will see you in a short while. Bye
okay.
for now, Bob.
Thank you. Thank
Now then, what have we got coming up? After this very short break, we have got Dr. Mike Shaw, who's going to be joining us. These are great views that we've got coming in from Argentina. Now, we need to keep a really close eye on these, and maybe some of the Slooh team can keep a good watch on our alternative feeds, or maybe look up which one uh, of them, multiple, is in the path of totality. Because I happen to know this one at the Parque Astronomica La Punta in Argentina. They're only going to get about a 73% partial eclipse. All right, so they're not going to get totality there, but some of our other feeds are, and the one that we've just seen, in fact. So we'll keep a very close eye for that. Don't forget, Slooh members, if you're watching this at slooh.com, go to the event page and you can be snapping some of these images for your quest. And if you don't know what a Slooh quest is, that kind of engaging learning activities. Whoa, look at that. Oh my word, that's the best ever so far. Goodness me. So very similar view to the one that we just had, but this is through a very specialist telescope, just like the Slooh Canary Islands telescope. It's watching the sun in what's called H alpha light. And we can see all this granularity over the surface of the sun, and we can see the prominences and stuff like that, as well as the moon slowly engulfing the sun. Anyway, we are going to go for a very short break, 1 minute probably, and then after that, Dr. Mike Shaw is going to join us. We're going to talk more about the eclipse. And if you want to get ready to take your camera equipment with me down to the Slooh Antarctica eclipse expedition next year to watch the December 4th total solar eclipse, the only total solar eclipse next year, 2021. If you want to photograph it, then Mike Shaw is the man to tell us exactly how. We're going to be right back after this short break. Welcome back to Slooh's live coverage of the Great South American Total Solar Eclipse. Why are so many astronomical phenomena so long-winded? Now, that break was slightly longer than planned, and that was due to my unprofessionalism because I had to increase my caffeine intake because we were up last night. We were watching the Geminids meteor shower live at Slooh. Dr. Mike Shaw, you were there last night. That was a pretty spectacular live shooting star party, wasn't it?
It really was. I mean, that was one for the book. So I was super happy to be part of that, Paul. Thanks again for having me on.
Now, you just told me before we came on air that after our live coverage, where we had those beautiful shots in the Canary Islands, where we saw, I don't know, I lost count of how many superb Geminids meteors we saw. You told me that you went out, you had an all-night photo session, so you're increasing the caffeine content as well. And you've just told me that you had a quick look at some of your photos last night and you're rather pleased. Is that right?
Well, absolutely, yeah. It was the trend continued all through the night, and there's a brief,
Brilliant.
without taking away from the eclipse moment, there's a brief window of no clouds that was predicted between 1 a.m. and dawn, and so I just set actually 3 cameras on. I have to confess, I did sleep because they were just running on a timer mode. But the timer mode activated properly and the hand warmers activated, and I was just scrolling through some of the reviews, and there's just a ton of Geminid meteors. So as I
Excellent.
think you mentioned during the write-up for last night's show, it was predicted to be a great show, and it was a great show. And that we saw some great ones last night, and there's some great ones in the still images. So excited about that. But look at this beautiful eclipse
I
progressing. It's
know.
just great hearing Bob
I know.
talking about it.
It's pretty cool, isn't it, to see this? Now, so this is one of our feeds from Argentina. Actually, let's just hop over to our Chile feed at our partners, the Institute of Astrophysics at the Catholic University there, and they run a teaching observatory, and Slooh has a huge dome there with some big telescopes that Slooh members control every night. This is their view, Mike. Now, you've been on a number of big trips. You often go out into the wild, to do some astrophotography. This is galling for them, isn't it? I mean, they've got a
Oh,
team of at least a dozen people up there. They've been working for months on it. They've installed these huge satellite dishes to beam back the live streams. And then on the day, this is what they get. I mean,
yeah. No, it is frustrating, and you just have to take a long view. I know a couple of people who are
mm,
down in Chile right now, enduring this, as you say, and there is this phenomenon that an eclipse can be sometimes called a cloud eater because for whatever reason it kind of helps dissipate the high clouds. But this type of fog, I'm afraid, is just terminal. And so,
yeah.
yeah, what can you do? It's frustrating, isn't it?
The thing is, you're quite right that, you know, you've got to do the things that are within your control. And I have to say, the Institute of Astrophysics down there, they have done absolutely everything. We've done so much testing for this over the last few months. They've done everything in their control, and the one thing they can't control is the weather. And
Mm.
we've all been on these trips,
Mm-hmm.
and it's just part of live astronomy in general. But this is why I live in the UK, as you know. I bought telescopes, decades ago, and they sit underneath the stairs because we don't have the weather for it. And then 2003, I discovered Slooh. What's this? Online telescopes I can control high up at the Institute of Astrophysics of the Canary Islands, 8,000 feet high on a volcano, with some of the world's largest optical professional telescopes there. Yes, please. I'll be able to do that from the comfort of my home. And I have to say, I'm a bit of a lazy astronomer, Mike. I don't know about you, but
Well, I wouldn't call you a lazy astronomer, Paul, but certainly it is nice to be able to, sit back and enjoy the view from afar. But that it is an incredible thing that we can observe these things from afar like this in real time. So it's just fascinating to watch the whole thing take place, though, isn't it, from Argentina?
it is, and it's going to be, we've got to cross fingers that we get to see totality and some of those amazing features that I was talking about with Bob over
Yep.
totality. Now, I want to talk to you. I'm not going to say arguably, you rank in the top one nightscape photographer in the world. There you go. I've said it. Anybody can argue with me on Twitter. Hop over to @AstroPRC and we'll have an argument about it. But Dr. Mike Shaw is the best astrophotographer, nightscape photographer in the world. An eclipse is a particularly challenging celestial event to capture. And for anybody who wants to either join us next year on the December 4th Total Solar Eclipse expedition, or maybe looking even further ahead, which I would kind of recommend that, more planning, more practice is what you need in astrophotography for the USA 2024 eclipse. Why is it so challenging, Mike? Is it because the sun's brightness is changing? But maybe there's the first thing, this is not just pointing a camera and telescope to the sun, is it? Because you would destroy your camera doing this. So what are these guys doing to be able to bring us these live views?
These are all excellent points. So the first thing that always has to be said is safety, and particularly with your vision. And so anytime anyone's contemplating undertaking a viewing or binocular viewing or telescope viewing or photography of a partial or a total solar eclipse, you have to keep your eye safety in mind. And the only way that that can be accomplished really safely is to use a proper solar filter. And by that, I've got a couple of examples here, but
Oh, great.
this is one for a camera lens, and you can see it's kind of a wrinkled up piece of foil. It's basically a very thin plastic sheet that's been metallized. This it's a commercial product that is mounted into a camera ring. And the reason that these are so critical, here's one for, this is actually one for a telescope that I modified to fit onto my wide angle lens. I'll probably talk about that in a minute. But as you can see, it's very reflective, just like aluminum foil in a way, but the metallization is thin enough to let the sunlight in. The main thing, you need to use a solar filter from a astronomical supply company and not a normal camera filter. ND filter, a neutral density filter, is a normal camera neutral density filter, doesn't block the infrared radiation, the infrared light.
Right.
And that can just kill your eyes, and it can kill your camera. So you really need to use a optical filter from a safety point of view. But it's both challenging and not so challenging in many ways. We'll talk more about it, but the opportunity, if you will, is that there are many different aspects of a solar eclipse that Bob and yourself were just talking about, and I'm sure we'll hear more about, from the partial phases to the first contact to the Bailey's beads or the diamond ring, whichever one of those happens, or the corona that Bob was talking about, just a spectacular thing to see. And then the partial phases, of which we're seeing right here. And I hope the viewers at home are snapping away and capturing these images of partial phases, because they can be put together to make a beautiful montage showing the progression of the moon's motion, relative motion, across the surface of the sun. So there's a lot of great angles to eclipse photography, but also just eclipse viewing.
So this particular view that we're seeing now is being done with a camera on the back of a telescope, but it could equally be, a really good quality telescopic lens and your camera. So this one is using what's called a white light filter, which is like those ones that you just showed us there. Some white light filters that we've seen in some of the other feeds show the sun as being a white disk, but with no surface features unless there's maybe a dark sunspot on it. Some other white light filters give this artificial yellow tone to it. Then we saw another feed earlier when I was talking about the granularity and seeing the prominences, and that was something highly specialized, and that was a highly specialized telescope like the Slooh Canary Islands solar telescope, which gives us this lovely hydrogen alpha view. So here we are then, Mike, these guys have got their white light filter in it. It's gradually getting darker and darker though. So do you have to change the exposure time or settings while you're photographing the partial phases of a solar eclipse?
No. A quick answer is not no, because the brightness of the sun itself doesn't change. I mean, you're quite right. If you think of the overall light coming into the camera lens during this progression, that is going to gradually decrease. But in terms of the brightness of the sun itself, that obviously doesn't change at all. And so to enjoy a composite, let's say, image of several of these different phases that all have the sun looking the same, then you'd want to keep the exposure settings of your camera the same. And I can go through a series of suggested settings for those, but certainly you want to keep that the same.
Okay, so what happens then at totality? Because I can remember some fairly frenetic activity on some of our past expeditions where,
Oh yeah,
you see white light filters being cast aside, because presumably at totality, if you keep your filter on, you see absolutely nothing, do you?
right? Yeah, there is a lot of frenetic activity. That's one way to put it. And if you just think of it from a viewer's point of view, what will happen during an eclipse? And we've talked about the crowd, that the people that are going to enjoy this, is before the eclipse. Like right now, if you wanted to just go out with your unaided eye and look at the sun, look at the partial eclipse, don't do that. Never do that under any circumstance. The retina of your eye doesn't have nerve endings, so you can't feel any pain, and the damage is almost instant and irreversible. It's a permanent loss of vision. So don't do that. But you can, of course, get these eclipse glasses, which have a thin layer of the film I just showed you,
Oh,
and then
well,
it's quite
Mike,
safe. Oh, yes,
Mike,
please.
we actually that's great. That's a great time to introduce this question that we've got from Carol Botha. Carol has asked, why do we need special eclipse glasses, and how do solar eclipse glasses protect your eyes, and how does one choose the right eclipse glasses? So great segue into that.
Great question. Hey, Carol, thanks for the question. What I would say is that safe eclipse glasses have a safety certification by, I can't remember if it's the ANSI or there's some sort of a stamp showing or certification
CE marking,
inscribed
isn't
on
it?
the
I think.
glasses. Pardon?
E marking certainly here, I think.
Yeah, and it basically will tell you that this is certified to protect your glasses, to protect your eyes. And all they are, it's the same type of the film that's trying to get the lighting on this. That is, whoops, here's the reflective side. Yeah, it's the same type of film that looks like that it's used to make these. And when you have these on, as Paul said, you can't see anything. They block all the light except for sunlight. But then when you look at the sun through these eclipse glasses, then you can see a miniature version of what we see here on the screen. If you think about the sun at arm's length, it's about the size of a pea held between your fingers, and you'd be able to see that using eclipse glasses. Now, back to Paul's question about what happens during the eclipse. Well, what happens is during a total solar eclipse, not an annular one, but a total solar eclipse, when the moon finally moves, it's a second contact. We have first contact, second contact, third and fourth. But at second contact, when the moon fully eclipses the sun, for a few seconds just before that, it is completely safe, only then, to remove your eclipse glasses, to remove the solar filters from your camera, and then you can just look at the eclipse with your unaided eye. And I tell you that is a transformative experience that you will never forget. It is the apex of the pyramid of astronomical phenomena. And as we were saying a minute ago, you can't get that through a telescope view, but just the overall feeling leading up to it, during, and then after it. It's what happens at the end of a solar eclipse is you immediately start saying, when's the next one? Basically, because it is such an addictive experience, and it's just something else. But to your point, I mean, it's all about safety. So you have your solar glasses on, and then maybe 20 seconds, 15, 20 seconds before second contact, you'll hear these alarms going off, and people are ripping off their solar glasses. They're unscrewing their solar filters. They're checking the focus. The diamond ring's happening. It's totality. It's just everything's going berserk, and it's a great thing.
Now, Mike, because we had timed a lot of these segments around the moment of totality on the volcano in Chile, so we're going to change the order up a little bit now. I'm still going to go over to our interview with Dr. Kate Russo in a few minutes' time. But could I ask you to come back in 25 minutes' time?
Of course.
And we'll delve a little bit deeper into photographing eclipses, because some of your best eclipse images are very much nightscape-like, so they are in a landscape, you see it. This particular eclipse is really quite difficult for them for any astrophotographer down there to do that, because we're very close to December solstice, which means down there the sun is really high in the sky, which means it's pretty darn difficult to actually get the sun and the surrounding landscape in the same kind of shot. So maybe we can talk a little bit about composing images, because I want to get some of this information from you, because for the Slooh Antarctica Total Solar Eclipse expedition next December 4th, we're going to be seeing the eclipse start almost as the sun rises. So it's going to be very, very low in the sky. And in fact, we're going to have an ocean landscape, a polar Arctic ocean, Antarctica ocean to kind of frame up. So that's going to be an interesting one. Mike, are you good to come back and see us in 25 minutes time?
Absolutely. I'll stand by, and I'll just say that in doing some research for my colleagues that are down in Chile right now, sadly clouded in, there is one combination of lens in one particular orientation that will work, and that's really about it. So I'll talk more about that when we come back.
Great. Thank you very much for now, Mike.
Thank you.
Wow. Now, if you haven't already bought Christmas presents and stuff like that, you need to go onto Amazon and you need to look up Dr. Mike Shaw, and you need to look at some of his astrophotography books, because my word, they will blow your socks off, and they are a fountain of knowledge if you want to get into that, even with a simple DSLR camera or anything like that. Now, coming up, we have got Dr. Kate Russo coming on, psychologist and eclipse chaser who has studied the profound impact of witnessing totality. She's interviewed hundreds, maybe thousands of people. So after this short break, we are going to be right back with Dr. Kate Russo. Bye for now. Great, Kate. Kate, we are going to obviously not have totality at this. Hello and welcome back to Slooh's live coverage of the Great South American Solar Eclipse. Studio, can you mute your audio, please? I would like to welcome psychologist and eclipse chaser, Dr. Kate Russo, one of our favorite guests that we have on Slooh shows. You're looking very Christmassy down there, Kate. Where are you?
Hello, I am in North Queensland, Australia, and it's after midnight here, so it's not Chile or Argentina. So, us eclipse
you're an
chasers
eclipse chaser. You're an eclipse chaser, and you're not seeing it in person. When was the last time you missed a major eclipse like this, which was reasonably easy to get to?
I know. I think it was around 2011 I had to miss that one because of a personal circumstance. Yeah. So it's always hard to miss one, but can I just say on behalf of all the eclipse chasers who are around the world emailing, messaging me as we speak. So I'm getting messages from everywhere. Everyone's watching, and we're all just feeling a little bit, a little bit stuck, but also very, very much feeling connected to all the people who are in the path of totality, and also feeling very a little bit upset that it's clouded out there. Like when the live feed happened and we saw the clouds there, we were quite upset with that. But
I
we
just
also
feel so
know,
sorry for them. Yeah, feel so sorry
yeah,
for them. But we're still kind of chasing down all of these feeds across Argentina, and this is a peculiar one, isn't it, Kate? We'll go into
yeah,
it maybe a little bit later, but it's a tiny bit of land mass. South America is so thin down there that the path of totality is there aren't many places you can say. But I want to go take a step back. You're a qualified psychologist. You put in even your CV, you're an eclipse chaser. When and how did that start?
do you know, I was a psychologist first, but I think my passion for travel was probably the thing that was there initially.
Mm,
So I had this desire to travel the world. I had um, this desire to experience all sorts of things in the world. And I think from a
mm,
very early age, I was curious about the experience of seeing a total solar eclipse.
okay.
And it wasn't until I finished all of my psychology training that I had traveled overseas that I then was in the right place at the right time to see my first total solar eclipse, which was in 1999. And boy,
Okay.
did my life just change after that one. So it
Where
was
was it,
really
Kate?
that was in France in 1999. So I was living
Okay.
in the UK at the time, and so it was just a little skip across, across the waters to see it. And from then on, I've tried to see every single total solar eclipse that I've been able to.
And I think
Um,
it's fair to say, isn't it, that most people who witness one total solar eclipse, it won't be their last. There's
yeah.
something that grabs you about it, and that's what happened to you. And then you kind of went on this adventure over the years where, as you say, you hardly missed a single total solar eclipse. What was it that captivated you and sent you on that path of eclipse chasing?
I didn't think it was going to capture me like it did. I didn't know I was going to become an eclipse chaser. It was just something that happened when I saw my
Mm,
first total eclipse. It just threw me. I knew what I was going to see. When
mm,
we're talking earlier on, I was listening to the interview you did with Bob, and you were talking about all the features that you see and all the fantastic alignments and all the astronomical um, elements that bring about the total eclipse. But really, it is about the experience of it. And when you're there um, on the ground, seeing these changes, being immersed in those wonderful changes of light and having that eerie darkness and those
mm.
just that primal fear that happens, when you experience that, it really, really does shake your foundation to the core.
It does.
And yeah, it really does. And it
So,
changes the way you think about things.
so was it that experience then linked to your professional psychology studies that prompted you to want to understand what those emotions, how this totality, this few seconds or maybe a couple of minutes at most, you know, how it can have such a profound effect on human beings and animals, but you study the human beings bit. Is presumably it was just your intellectual curiosity that wanted to understand that greater.
Yeah, well, because it was like I had my psychology practice in one hand. I was a clinical psychologist and I had my psychology world in parallel there. And in my personal life, I would go off and chase eclipses over here. And it really struck me that in both of these worlds, I was dealing with a transformative experience. So in my personal life, my life would be completely transformed every time I would see a total solar eclipse. And in my clinical life, I would help people try to um, identify ways in which they can bring about change in their lives. And it always struck me that the total solar eclipse allows you to understand and appreciate life in a way that we don't need to go through any difficult life experiences. We can learn something very profound and think about life in a very profound way just by experiencing something so unique and different. It allows us to feel very insignificant and connected to something so much greater than ourselves. It really is something that is very difficult to communicate, and it's a very unexpected side effect of seeing a total eclipse, that anyone who's seen totality will understand this. But if you haven't experienced a total solar eclipse, if you've not been in the path of totality, it probably sounds completely outrageous.
It does. I
But
mean,
if you've been
Bob
there, you
described,
understand
yeah,
it.
but Bob described it earlier with a superb word. He said it was unworldly, and that's what
Yes.
I've experienced, Kate. It's just this feeling of knowing things around you are changing in a way that your brain can't comprehend it. It can't analyze it because it's the first time you've seen it. And frankly, I get that same feeling every time I witness it. It doesn't seem to subdue or diminish the more totalities I see. So, but to get to the bottom of this, you started uh, interviewing a lot of people, didn't
Yes.
you? And researching it to try and gather up, this information, this collective knowledge of the emotions that they
Yeah.
suffered. What kind of things are there common strains that you found throughout all of these people that you interviewed about witnessing totality?
Yes, because I do think there's something very profound that we can learn from this experience, because, you know, it's not. It's about trying to understand what we can learn from this, and it's only by listening to people's experiences. And interviewing people is the best way. But the problem is, we can't describe what it's like. I mean, this is fundamentally the thing.
Yeah.
We have no words to describe it. And so initially, the first few years, I was talking to eclipse chasers because we're the best ones to be able to put words to it, right? We've gone to experience it again and again, so we're the ones who are most likely to be able to put words to it, and that's been really great. But over the last 5 years, I've been researching more people who've experienced it for the first time, and I think there's something very powerful about that too. And so, pooling all these experiences together, there's something very unique about the awe experience and about what that allows us to feel. There is something that it's still very difficult to tease out, and maybe we'll never get to the bottom of it. Maybe we'll never be able to put words to it. But what we do know is that it's just very profound for a lot of people. And not everybody who sees a total solar eclipse will become an eclipse chaser. We do know that. But for some of us, like myself and yourself, it just seems to capture us, and we become so driven to see it that it just becomes not just a little hobby or a side interest. It actually becomes a big part of who we are, a big part of our personality, and something that we just are so driven.
A big driving force. And it's can you describe your, if there is such a thing, your best total eclipse experience, and try and convey what made that particular one special?
I think, Paul, this is almost like asking a parent to
Favorite
choose
child.
between their children. I don't know. I
Okay.
don't know if you could ever do this, right? People will say, I think maybe that it's always your first one because you think you know what's going to happen, but actually it's so unexpected that you will never capture that unexpectedness that comes with your first one. So I think your first one is so special. And I've written about that a lot, and I've interviewed about that a lot. So I think there's a lot of information about that. And in fact, I think one of the most wonderful pieces that I've written about that I published earlier this year, and I've put an extract on that on my website.
Oh, great!
Which
your
I think
website address being? Tell us what your website
Being in the
address is.
Shadow. beingintheshadow.com, and I just updated it within the last few days. But I think I wrote the article for Aeon eclipses.com, and I think I went into a lot of detail about it because I think it just captured the elements which came through with all the interviews that I've done over the years. So I just made sure it was almost like capturing all the elements that I've experienced, everybody has experienced, to try and capture it into putting the words to my own first experience, if you know what I mean. So I think that is a very powerful way of conveying what it is like to experience a total eclipse. And the thing is, we can't do it in quick sound bites, and that's the problem. So I would say if you want to have a look at it on my website there. But my other favorites, everyone's a favorite because they're also, everyone is so unique, different, and has different special things. I tell you what was really special, like the last total eclipse, and I was in Argentina last year, and I was with a group of very close friends who were eclipse chasers, and we were north of Mendoza, and I had seen shadow bands before, and I hadn't really got that excited about them because I didn't really, I just didn't really appreciate what they were. But we experienced totality, which was incredible in our location. It was just so grand and epic, and it was just wonderful. And then we turned around, and you were talking with Bob before about sometimes the things that you see are behind you. And we turned around, and it was the whole valley behind us was like there was this rippling, like there were these waves, and it was going across the whole valley, and it was just moving. And I've actually got goosebumps here now talking about it.
Just thinking,
because it was.
This is the thing.
Oh,
Yeah. Whenever I talk about moments of totality that I've experienced, it can still bring me to tears, Kate. It's the most stunning thing. But all of the people who are in Argentina at the moment, they're watching this eclipse. When we were in the USA for the 2017 Total Solar Eclipse, we were in this beautiful location, lots of guests there staying where we were, out in the countryside. And everybody had their eclipse glasses on, and they were watching a view just like this. And we were doing the live show as we always do. And I kind of shouted over to everybody, look, come over here. Because what I was seeing was all of these wonderful, wonderful features which were behind me. Shadow bands. We were seeing, we got a colander from the kitchen. The chef came out with a colander, with lots of holes in it. We held that up, and it cast a shadow of hundreds of tiny crescent suns that looked absolutely beautiful. We looked below the trees where we also saw the shadow of the leaves as little crescents all over the place. But then, as the moment of totality was approaching, I got everybody to face the other way, and started to see, in fact, it was still behind us, starting to see the umbral shadow, the moon's dark umbral shadow approaching on the horizon. And there are so many of these effects. People are so focused on the sun that they miss some of these most extraordinary events. And then, of course, during totality, make sure you do at least one spin, one 360 spin, to see, the full sunset, sunrise view that you get. I wonder, Kate, let's go back to our Chile feed, can we? Because I know they're in the clouds, but we're a minute away now, or thereabouts, from what would be totality for them. I mean, it is totality, but it's happening behind those clouds. And I would just like us to carry on watching that to see just how dark it gets. Now, with some of these feeds with cameras that are on automatic exposure, it may auto adjust, but I do wonder if the studio can bring that up, whether or not we'll be able to see an obvious darkening as the moon totally obscures the sun from their location. So, Kate, you were going to say something.
Yeah, because it reminds me of the Faroe Islands. It was, you were there as well.
It is.
Yeah, look
There
how
it
dark
is.
it is.
Wow, a minute ago that we were seeing them in what looked like daylight. Gosh, that must still be quite an eerie feeling, do you think, Kate?
Absolutely. This is exactly what happened in the Faroes. We couldn't see anything, but underneath that cloud, it was so dark and eerie and oppressive. Look at that. Like, you can even see even more dimming. Like you
Exactly. And we are
You can
now
actually
at the
see
moment
even
of
more.
totality for
Yes.
them. Yeah. So that
Yes.
they're
Yes.
within, they're having
Yes.
their 2 minutes and 8 seconds of total darkness. I bet that feels just as eerie as it
Look how
does.
dark. Yeah.
Exactly, even
Yeah.
if they could see the sun, because this is happening for them at 1 p.m. in the afternoon, uh, on very close to be the longest day of the year for them. So this is happening in midsummer, basically, or the start of summer for them. Wow, that
So
must still be very eerie.
yes, it's not about the fact, because I think when I first was clouded out, I kept thinking about it's the things I wasn't seeing. But actually, look at what they're experiencing, that darkness. You don't
Yeah,
get to see that dark when it's, there's usually some twilight around, right? You
yeah.
don't see it that dark during the middle of the day. That is very, very impressive.
We
That
we
must be
should
so
stick on.
eerie to be up
Yeah.
there. Yeah.
Yeah, we should stick on this, please, studio, because it will be interesting to see, as
When
the
it
the
comes back.
moon, yeah, exactly, the
Yeah.
moon leaving the sun's disk, and see just how much difference it makes. I can remember, I think it was the African eclipse, Kate, that we were on. We did have quite a lot of cloud cover. These poor guys are virtually in the layer of cloud. So they're not going to see this effect. But when you have some higher cloud off in the distance, I think we saw it in Idaho as well for the USA eclipse. Um, you, it's quite fortunate if you've got distant cloud, because you actually see the shadow, the umbral shadow on the top
On the cloud.
of the clouds, and that really adds this enormous amount of perspective to this whole thing. But you mentioned earlier, you used the term fear. Do some people, is that an emotion that you've found is common, some form of fear in totality observers?
I, yeah, it is. It is almost everyone that I interviewed mentions this primal fear. They may not use the word primal fear. A lot of people
Mm,
do, but this primitive fear, they say, it's this fear that they find that comes from within. They don't really know what it is or what they're responding to, but it's this sense that something is not quite right, and they don't know what it is, but everything is on alert. The hair on the back of their neck stands up.
mm,
They're just on alert. And I think it's that element that you were referring to earlier. We respond to the differences in light. And
mm.
speaking of which, can you see the light coming back? Can you see
Yes,
you
just
can see the,
we
oh,
can
look
just
at
see it.
now.
Yeah, we can start
It's
seeing the,
really,
the
really
the
coming back.
horizon again.
Yeah.
Look at that.
Yeah.
Oh,
And
well
if you put
spotted,
that on
Kate.
time lapse, you'll be able to see that actually sweep across really, really rapidly. That is beautiful. And that is actually very dramatic.
It is.
That's a
It
big
is.
shift.
I'm surprised at how dramatic that is, given that they are
Yes,
in that cloud layer. Now we're starting to see. We can see people moving again. That
yes. Yeah.
that I know they can't actually see the sun. They can't see the diamond ring. They can't see Bailey's beads. They can't see the corona. But I bet you that's been a magical experience for them there.
Yeah, yeah. I remember my first experience being clouded out was in Jinshanwei in China, and I kept thinking what I lost, what I didn't see, and I
Mm,
didn't appreciate that um, that sense of the darkness and what I could have experienced.
yeah.
Um, and I see that there now, just watching it. Like I can appreciate what they saw. There's a part of me that wishes I was there, and I'm so glad
I
to be part
know.
of it here. But it's
I know.
I just really feel for the people there, and I hope
I do.
that magical moment that they could actually still feel that sense of being on that volcano and have that darkness sweeping over them. I hope they felt that was magical for them.
Yeah, I do. I mean, when I spoke to Daniela, last week on different calls, setting
Yeah.
all of this up, and also this morning as well. Oh, look at this. Oh, I hope this is a location which is in the path of totality, Kate, because we may be moments away from
Now this is
totality here.
bittersweet because this is where I should be.
Oh no, that's rubbing salt into the wound, Kate. I'm
It is
sorry,
a
we didn't
little.
do this to you deliberately. Oh my word, come on. We need to see if we can, studio, if there's anything on the top of that feed, because if it's that last little bit of the sun that gets eclipsed, is where we might see the diamond ring. So Oh no, please cut back to that if we can, studio. Kate, well, I think we need to stay on air now until, so excuse future guests. Come on, we need to see the top of that feed. Move the telescope, move the telescope. Um, oh my word, that's tantalizing, isn't it? Oh yeah,
There you
here we
go.
go, here we go. Right. Okay, so is that, I hope we haven't missed it. I hope we haven't.
That's still a few minutes to go, surely.
Well, I'm hoping it's a few minutes to go rather than a few minutes past, Kate. That's I haven't got the timings for this particular location, so that looks like it's
Oh, I
getting a
see.
bit bigger to me.
Bigger.
So, studio, don't know if you can do a replay on that. Yeah, that's definitely getting bigger to me. Now, potentially, unless that was precisely where you were planning to be, potentially that's they were only a 99.9% if they were outside of the path of totality. But we'll leave that up to the studio. But we will keep on with you, Kate, if you don't mind, rather than welcoming Mike or Bob back, because let's go back to this emotional response to
Yeah.
totality. And one of my eclipse highlights was um, a trip on, it was on the transcontinental eclipse in the USA in 2017, and we stopped off at Nashville Zoo, and we've got that clip on the Slooh website that people can see, and we did a walk around with one of the keepers there for 45 minutes, talking about a study that they were doing, and they basically crowdsourced this study. And they had lots of webcams in all of the animal enclosures, and they were asking all of their normal visitors to be watching at home and to be watching the animal behavior. And we saw some extraordinary sights in that. And the first thing that happened just before the moment of totality was the animals, a lot of the animals went a little berserk. And I wonder if that was a representation of the primal fear that you've described there, because it, from my experience of totality, what makes describing those emotions so difficult is because they come from an animal part of my brain, and it's why I can't comprehend it, it's why I can't analyze it in a normal
Yeah.
way. And then of course we saw the animals just laying down and going to sleep. Have you kind of linked any studies between the human behavior that you see and animal behavior?
Yep. So there's a lot of layers in your question there, isn't there?
Yeah, a lot.
Well, humans, we're unique. We're unique because we are humans. We make sense of our experiences, and we are able to interpret and put meanings on things. Whereas it's very hard to know whether other animals are able to do that. We think not, but other animals really do respond to changes of light. For example, we know that other animals become more active at, either nighttime. We've got nocturnal animals or crepuscular animals that are more active during twilight. So it is very common for some animals to become more active during changes in light. So I think that's probably what they were responding to. So animals like, bats and certain mammals and insects. So I think those are the animals that the types of behaviors you were probably seeing changes to as the light was changing during totality. I think it's probably that more than them reacting to, oh my God, there's a total eclipse, what's going on?
Right.
I think that's probably more of a human response, to be fair. But I think, the part of our brains that is responding is part of the more primitive response system, in that it's our stress response, and we are under enormous stress, and our there are parallels to the stress response and trauma response, because we almost dissociate. There are high stresses involved, and instead of it being a trauma reaction, it's actually a really intense awe response. And so I'm still trying to tease out what we can learn from this, because it's a positive experience rather than a trauma response that keeps us stuck in that loop, if you know what I mean. So there's something very positive about the experience rather than being a traumatic, post-traumatic stress disorder thing.
I'm going to take that with me on our
Right.
expedition, because I love trying to analyze this stuff, you know,
Yeah.
both before, during, and after. You know, my brain is just trying to analyze what's going on. What is that feeling that I've got? And I got very close to it actually in the American, the USA eclipse, when I was trying to tune in to what's going on. And that was when I had this little revelation. It's because my senses are overwhelmed because of the light changes, because of the contrast that I'm seeing, those things that, you know, Bob was talking about with the sun turning into a spotlight. So your shadows, all of the shadows being very coarse. And it was, that's what I kind of picked up from that. But as I go on more total eclipse adventures, I want to try and it's just me. I just want to try and understand these. But you said something a little bit earlier, which I thought was lovely. You wondered whether or not we'd ever understand this phenomena and the impact it has on humans. And I thought at the time when you said it, I kind of hope we never do get to fully understanding it, Kate. You know, it would be nicer for it to, you know, remain a little bit of a mystery, wouldn't it?
Paul, maybe we'll be having these same conversations in 30 years' time. You know, we'll be doing a
I
live
hope so.
broadcast from somewhere saying, you'll be like, Kate, tell us why we're having these things.
Come on, Kate, you've been studying this for 30 years now. Have you not got an answer for us?
But you know, the best that I can say is that there are three aspects to it. You know, there is the element that it's a scientific, you know, the coincidence in scale, and there are so many fantastic elements that's scientific aspects to it, which are phenomenal. The second element is that, you know, how we feel at the time, you know, the changes that we have, how the temperature drops, how we feel that on a visceral level, the primal fear that we have, the changes in light, and how we react to that feeling of awe and everything that goes with that. But the third, which is the thing that's the hard thing to really verbalize, is how it transforms our lives, how we really think about it, how we make sense of it, how it impacts upon our sense of our being in the world, how we make sense of time and what time means for us, our time on Earth, and from past, present, and future being on this planet, and what it means for our life. Life is fleeting, and the eclipse is fleeting. You know, we're only on this planet for a very short period of time, and it's about how we spend our time. And that fundamentally is what it's all about. And these are very hard concepts to put into quick sound bites. So that's why we'll always be talking about this. 30 years' time, we'll be having these same conversations.
Absolutely. And it's also why any of our viewers today, if they haven't witnessed totality, they need to make sure that they witness it. It has to be
Yes.
on their bucket list, big time.
Absolutely.
Kate, thank you so much for joining us today. It's always an absolute pleasure. As you say, it's incredibly late there. It's past 2 a.m., isn't it, in Australia at the moment? So
Yeah.
thank you so much for joining us and staying up. Hopefully, we still have a few opportunities to see some totalities as the moon's umbral shadow whizzes across the face of Argentina. Kate, thank you very much for joining us. Take care.
Take care. Thank you. Good night.
Now then, coming up, what have we got? We are still going to keep our eyes peeled on these feeds, these live feeds coming in from Argentina, because we should get totality at one of them. This one that we've been seeing here from the Parque Astronómico La Punta in Argentina, they are roughly at maximum partial phase. They're only going to see a partial eclipse from that location because they're outside of the path of totality. But we're going to keep an eye on these other feeds because that one, some of these are looking pretty darn close. That one down in the bottom left-hand corner is looking pretty good for totality. What's it doing? Is it teasing us? They've got a little bit of cloud. We are going to be back in a 1 minute's time, I'll jump straight back on. If any of these go to totality, we're going to welcome Bob Berman back onto the show after this short break. Bye for now. Hello, I've got to come back. There's the diamond ring. There it is. We've got our first totality shot, everybody. Wow, look at this. I'm sorry, Kate. I got you off the show too early. Oh no, we've gone off to another feed. No, there it is. Look at this. Oh my word. Bob, are you on the show as well? Are you coming to join me for this miraculous moment? Hey, Bob, what do you make of this?
Whoa, love it. I love it. There seems to be a slight little bit of very high clouds that's
Yeah.
slightly fuzzing it, but it's still marvelous, isn't it?
We are. So I think we're just seeing, aren't we? Still a little glimmer of total sunlight. It doesn't quite, it's very difficult to see because of that light cloud. But you know, we can see. Yeah, look, that's not quite total yet, is it? It's just going into it. What do you think, Bob?
I can't tell. You mean at about the 2 o'clock position? A
Yeah.
little direct
Yeah,
sunlight?
it's still looking a little bit bright over there, isn't it?
I don't know. It looks awfully totalish to me.
It does.
It's just
Those
wonderful.
few
Oh,
seconds.
yeah.
So we were
Awesome.
talking,
Awesome.
Bob, about the corona before. Now, the corona is this incredibly tenuous, almost ephemeral feature of the sun. Look at this, the clouds are clearing. It makes it really difficult to see through this light cloud. But here we go, Bob. We can see it now. Oh, go on, clear away clouds.
I'm actually, and this is from Argentina, not Chile, correct?
Yes, this is from Argentina because unfortunately everybody in Chile got clouded out in that thin path of totality. But here we are in Argentina as that
Well, I'm a little
umbral shadow.
surprised. Frankly, I'm surprised at what we're seeing because we're only a year past sunspot minimum. That happened last December. And normally at minimum, you get very prominent coronal streamers like wings that come from the equator, and the rest of it is pretty blank. This looks more like almost circular, almost even corona all around the sun.
Here we
which
go,
is
Bob.
more,
Diamond ring again. Bing! Wow, look at that. Oh, that was a classic diamond ring, wasn't it, Bob?
Oh yes, that was gorgeous, gorgeous diamond ring. But don't you
So
think that corona looked more like evenly around the sun?
it did, it did. So that's going to be very interesting actually to, you know, kind of analyze afterwards. And with so many feeds available, an awful lot of astronomers are going to be looking at this. Now it's gone dark again. And if you remember earlier, we were talking to Dr. Mike Shaw about this. As soon as that first speck of direct sunlight comes out again, that's when all of the astronomers there and all of the observers there are sticking their eclipse glasses back on, they're sticking their solar filters onto their cameras. Otherwise, you're going to do some severe damage. So that's why it went dark. And it's why it's such a fleeting moment, isn't it, Bob? And it never lasts long enough.
It's true, and like Lot's wife, we can really be penalized. One of my readers in one of my magazines that I write for has told me that he's been permanently semi-blinded, doesn't have normal vision because of looking directly at an eclipse in his youth, a partial eclipse in his youth. So yes, it really can happen.
And people should not be tempted to use anything other than a certified filter or eclipse glasses. And the other thing that I always say to people is if you find an old, you know, let's say you've got a pair of Slooh 2017 USA eclipse glasses. If you're thinking of using those for 2024, no, don't be a cheapskate. Buy new ones. And before, even on a brand new set of eclipse glasses, before you use them, always hold them up to a very bright light source, an incandescent bulb or something like that. And if you can see the slightest little white dot, which might be a pinprick or a scratch on them, throw them away, because even that minutest pinhole, Bob, that would let sufficient light through to give you permanent eye damage, wouldn't it?
It could, yeah, depending on the size of it. Although I don't know if we're being cheapskate or not, but our tour company, we reuse eclipse glasses for years after years. But we do check them to make sure they're
Okay.
intact, don't have anything wrong with them.
Okay, so we won't see you for now. Anyway, let's move on, Bob, because totalities, wonderful thing to experience, but they totality and eclipses have been described and written about in fiction for quite some time, haven't they? And wasn't there a Mark Twain story?
Sure, in a Connecticut Yankee in King Arthur's court. Yes, he saves himself by seemingly predicting the blacking out of the sun, so that instead of getting burnt at the stake, executed, he saves his life. Yes.
Wow, so that's it's a I always think I'm as you know I'm only a few miles down the road from Stonehenge in the southwest of England, and I often think about the amount of power that the Druids and others must have had to be able to predict these phenomena. And solar eclipses certainly are probably the biggest one because of how onerous and fearful they can be. I think there was a Chinese um, court astronomer who was executed because he got it wrong or didn't warn the emperor that there was the sun was about to be snuffed out. But it must have wielded a huge amount of power to be able to foretell these kind of events. So they happen on cycles, don't they? Solar and
Yes.
lunar
And
eclipses.
you have to be pretty darn good because, I mean, first there's the Saros cycle, but that's really not when several periods of the sun come together. The moon's orbital cycle and its close to far away cycle, and a number of cycles have a common denominator. Common denominator. You're talking about you're
Hey
talking
Bob,
about
here's
just
it.
under 20 years.
Just to explain this, we've got a little replay running
Oh
of that
yes.
totality moment. So please carry on talking.
Sure, but that's unfortunately the cycle involves a third of the day, so that even if you've predicted that next occurrence of an eclipse, it will happen uh, 120 degrees of Earth's longitude away from your location. So you still won't really accurately predict the next eclipse. You need three Saros cycles, which is 54 years in 1 month, before you're going to get a repeat. So, boy, they had to be pretty good because that's pretty much a human lifetime back then. You had to be pretty
Exactly.
darn good to predict something that was going to happen one human lifetime in the future.
So if you were in any single location on Earth, what would be your likelihood of witnessing, assuming clear skies, what would be your likelihood of witnessing a total solar eclipse in an
Oh, well,
ordinary
the
lifetime?
answer is for any given location, you'll get a total solar eclipse once every 360 years on average. And of course, if it's cloudy, you can wait another 360 years. So the odds are not in your favor. New York City last had one in 1925. LA last had one in 1923. And then you wait, as I say, an average of 360 years. That's why we travel or
Mm.
take people to these expeditions to see them, because not likely to come to you. You've got to travel to them.
Exactly. Now, is it a coincidence that the continental USA has had an eclipse, a total solar eclipse, in 2017, but is getting another one in 2024? That sounds to me like a London bus. You wait for ages, none come along, but when they do finally come along, two or three come along at the same time. Is that just a coincidence, or does that happen regularly?
Uh, not regularly. They are really all over the place with it, and so
And
it's
2024 is going to be lower. The path of totality, Bob, for 2024 in the USA, it's lower than the path of totality in 2017, isn't it? I think.
well, it depends on where you are. The eclipse path starts in northern Texas in the United States, travels northward, will cover Cleveland, then Buffalo, then Rochester, continue to the northeast, cover Burlington, Vermont. But now you're getting to the cloudier northeast. After all, it is April. at that point. So, and then go into Maine. So it really depends upon where you are and
Okay.
the luck of the draw there.
So we've watched this replay a couple of times. There's been a few little what look like purple regions on there. You mentioned a layer of the sun earlier, and it's quite an elusive layer, the chromosphere. And I seem to remember you telling me that you haven't actually seen that during many of your numerous totalities that
Yeah,
you've
I
seen.
saw
What
it
can you tell us about this?
yeah, I saw it for the first time actually on the eclipse 2 years ago, and I was inspired by my wife, who almost blinded herself and saw it accidentally. She was looking at the sun with binoculars. Binoculars are a great instrument during that famous 2017 eclipse we had in the United States. And totality was almost over, and she was still looking at it. And just when I was about to tell her, well, take those binoculars down because you don't want to get even a moment's worth of direct
Yeah.
sunlight with binoculars. That would be deadly. But she was still looking at the sun. And that's what you have to do to see the chromosphere. When suddenly she shouted out, "What's that?" And then she took the binoculars down because there's a very blood red layer. It's called chromosphere, meaning color, but the color is red. That's just located alongside that brilliant photosphere, but you'll only see it when totality is almost over or just before it begins. So
Mm.
you got to be very quick on your feet. I don't recommend it. I think it's too dangerous because a
Yeah.
moment later, the full sun can come back, will come back, and could
Yeah.
blind you. So you have to be willing to keep watching through binoculars, ideally, as the eclipse is over, and yet be quick enough to close your eyes or take the binoculars away before that brilliant light comes back. And in those few moments, that's when that blood red chromosphere can appear.
And the color of that is one of the most stunning colors I think
Oh
I've
yeah,
ever
because
seen.
it's pure H alpha. You're seeing just a
Mm.
layer of 65, 63 angstrom emissions caused by hydrogen in its excited state, and only can be seen during eclipses, total eclipses.
So, Bob, I've got a couple of viewer questions for you now, if you don't mind taking those. And the first one's from Yari, and Yari is asking, and actually this is similar to the question that we had earlier about the speed and path of the umbral shadow as it crosses Earth. And Yari's asking, does the path of the moon cross? Sorry, wrong question. How much is the no, that's the wrong question as well. Right. Does the path of the moon cross the sun differently depending on where it happens on the globe?
Well, the speed is different on the globe. Your eclipse is going to be shorter if the eclipse is a near polar eclipse, like the one that you saw in the
Mm.
Faroe Islands, north of Scotland, because at that point, Earth is not rotating very quickly. You might recall that the speed of Earth at the equator is 1,038 miles an hour. The speed of rotation at the poles is 0. So now you have the moon's shadow, moon casting a shadow. Its orbital speed, we've already said, is 2,288. So the shadow is moving along at that speed, hitting the Earth, whoosh, whooshing across Earth. Now, if you're at a place where Earth isn't moving, that is a very northerly place, such as the eclipse you saw, Paul, a few years ago, well, then that shadow is going to go over you and then pass you pretty quickly, and it's going to shorten the eclipse. But if you're
Yeah.
as you were in your African eclipse, if you're closer to the equator, then Earth is moving in the same direction as the moon's shadow at 1,038 miles an hour, so that you are moving along with the shadow essentially to a degree, and so that can greatly lengthen the length of the eclipse.
Okay, so for our Antarctica Slooh expedition next year for the December 4th, we're very far south. Um, the the speed, I was looking this up, the speed of that umbral shadow, the moon shadow, crossing where we're going to be, when it first touches down, it's going over 35,000 miles an hour. And even when it reaches our viewing location, it's going to still be traveling at around 7,000 miles an hour. That's in comparison to the path that we were seeing today across Chile and Argentina. Um, around 2,400 miles an hour, 2,500 miles an hour. So there's these huge changes. And there was this other question earlier which came in: does latitude also change the width of this path of totality? Because we've said that where the path of totality crossed Chile and Argentina today, it was only 56 miles wide. So you had to be within that thin, narrow path to be able to witness totality. Does that change depending on what latitude you're at,
Oh, it
Bob?
does. It does, Paul. Yes, because again, if we picture the moon shadows being rather like an ice cream cone, fattest at the moon and then tapering down narrower and narrower, you can see that if you're at a latitude during the path of the eclipse where you're closer to the moon, you'll intercept a, a bigger diameter slice of that ice cream cone. Whereas when you're at a latitude that's generally a higher latitude, a more polar latitude, you'll be at a thinner section of that moon shadow, as we can see in this diagram. And so that definitely affects how long the eclipse will be.
Okay. Another couple of questions here. First one's a quickie. How long do solar eclipses last, Bob?
Well, the maximum is about 7 minutes.
And this is
We
totality.
That's
The
totality, and
duration,
the
right?
eclipse itself will be about an hour in all cases for to be covered up, and then another hour to be uncovered. But those are the partial phases that are maybe interesting to some, but they're really preludes to the real main event. So we're talking about totality there, and the longest of this century occurred on July 10th, 1991, the total eclipse that was longest in Baja California, uh, where you had 6 minutes and 40 seconds. That's
Wow.
approaching the 7 minute absolute maximum that you're going to get. So that was long, and no other eclipse for the whole rest of the century is going to equal that one.
Okay. Now, if I can ask the studio to line up that replay of totality again, because question from Yvette, who missed, Bob, your earlier explanation about this. This first totality phenomena that we see, the diamond ring. Whenever I've been at an eclipse where there's been a lot of people around, the excitement at the diamond ring is where you hear the big whooping. Then it goes into totality and things start to get a little bit more subdued. But the diamond ring is the one that most people seem to get excited about and want to express. Can you tell Yvette again what the cause of that diamond ring effect is?
Yes, just before totality, when the moon has blocked out almost all of the sun, there is usually one last speck of the sun that's coming through some lunar valley right at the limb, the edge of the moon's disk. And that last dot of sun coming through gives you the full brilliance of sunlight, whereas at this point, you're still getting a dimmer ring of the corona, the first glance of the sun's corona or atmosphere around the entire edge of the moon. So the appearance really is of a lesser brightness ring with a dazzling pinpoint. And let me add that in real life, it's far more impressive than any photo for the simple
Yeah,
reason that in real life, that brilliant dot of sun is a pinpoint. After all, you're only looking at sun coming through some lunar valley, so it's
yeah,
only a few miles wide. Whereas cameras capture that gradation of brightness by overexposing it and making it bigger. So in
yeah,
photos, the diamond of the diamond ring looks like a big blob. And it still looks nice in a photo. But in real
yeah,
life, it's not a big blob. It's
yeah.
a pinprick. It's a little tiny, but nonetheless intensely brilliant spot, unlike anything you'd ever encounter in real life. We don't see, I mean, stars are pinpoints, but they're not that bright.
Mm.
So here's this brilliant, but tiny little pinpoint that does not resemble any photo. It's better
Yeah,
than
it
any
it
photo.
it is an extraordinary feature of a total solar eclipse, and I think made all the more special because it is a moment in time, and you see it flare up and you see it flare down. It's a beautiful sight to behold.
Yes, I noticed
Um,
in the Slooh book the Saturn above it, the wonderful
Mm.
Slooh book that presents remarkable essays about space. Again, in the James Fenimore Cooper essay, The Eclipse, no mention is made of the diamond ring, not just because the term hadn't been invented yet. It wasn't invented or originated, let me see, until 1925, but because no one knew to look for it. So he did not, Cooper did not say, and the diamond ring was spectacular and everybody oohed and awed, because it had not been ever written about. Nobody knew to look for it, and even if you saw it and didn't have a name for it, it didn't register. So this is something that we now, for the past century, have been admiring, but they didn't during all the centuries of previous eclipse watching.
Wow. It's one of my favorite little moments, I think. And the lovely thing as well about the diamond ring is that you see the first one just as the moon is about to cover, but you also have this lovely knowledge that you're going to see it again, when the moon starts leaving the sun's disk as well.
And that's a mixed bag, of course, because the first one heralds the greatest experience of your life visually, which is the total solar eclipse. The final diamond ring tells you that the glory is ending. And so,
Over for another one.
again, going back to our analogy of relationships, if there was some moment, let's say a honeymoon or a first date, that captures the beginning of a relationship that you'll always remember, great. But few people celebrate the divorce visit to their attorneys, So the final diamond ring is like that. Never mind. I don't even like my analogy, this metaphor. It's terrible. Forget it. Let's move on.
Let's move on. Bob, what have we got? There's Do other planets get to see eclipse events? Anything similar to what we've been witnessing today?
No, with the Slooh telescopes, all the users of Slooh telescopes can see the shadows of the Jovian satellites on Jupiter. So there's moons casting shadows, which tells us that if you could be there on the cloud tops of Jupiter, you'd be seeing total eclipses
Mm.
produced by all four of the Jovian moons. The difference is those moons are bigger than the sun appears from Jupiter. From Jupiter, the sun appears 5 times uh, smaller, and those moons easily cover up the sun too much, so that you don't get the prominences, you don't get the phenomena that we see on Earth. So you do get an eclipse, but you get rather too much of an eclipse.
Okay, the sun totally blotted out without being able to see any of those lovely edge details that you were explaining in this cosmic coincidence. And we can
Yes,
see it
but
still
but
here,
can
can't
we
we,
go
Bob?
back to this? Can we go back to this strange event where we did not get the phenomena of the coronal appearance that had been predicted, and I don't understand why. Instead of the sort of wing-like structure, we had a more symmetrical looking
Mm.
appearance. This all has to do with magnetism. All the
Right.
sun's phenomena are magnetism taking different forms. Here on Earth, we don't think about that because we humans can't feel Earth's magnetic field. We don't think about it very much.
So here
But
we've got it, Bob, on a replay again. So
yeah,
explain the phenomena
well,
that
well,
you're looking at.
normally at sunspot minimum, the sunspot cycle is 11 years long. We had our last minimum December of 2019, exactly a year ago. And so we're very much still around sunspot minimum. Normally, you'll see blazes of light, the corona uh, on each side of the sun's equator, but not forming a even ring around the whole sun the
Mm.
way we're looking at right now. This is more a phenomenon of sunspot maximum. We'll not have sunspot maximum until July of 2025, or so it's predicted. So we're several years away from maximum. So I don't know why the sun looked the way it did today.
Okay, that's interesting, Bob. I mean, we have seen, quite a lot of unusually high solar activity just over the last couple of weeks in the Slooh Solar Telescope. So I wonder if it is connected with that. And I know there was a recent story, in the Astro Press that, maybe solar activity is ramping up a little bit faster than we first
It
thought.
must be. It must be. I mean,
Yeah.
it has ramped up from a year ago was the actual solar minimum, and the fact that we've had aurora recently shows that there has been a good amount of solar activity. So I think you've hit upon it. I think there's been enough unusual solar activity, unusual for this part of its cycle, which is usually wimpy, to have created the corona we saw today. In other words, it's sort of a local, out of sync phenomenon that gave us the appearance. And I think scientists will be talking about this very odd, anomalous, strange coronal appearance of the eclipse we just witnessed that's different from what we'd normally see. Because again, magnetic phenomena, we're just starting to really get into it. I mean, most dog owners don't know that it's been recently found that when you walk your dog and you're waiting for the dog to urinate, that dogs circle around and generally align themselves with Earth's magnetic field. Dogs will face north-south before they'll pee. And we never used to know that. I mean, everybody knows pigeons and birds and some other creatures follow Earth's magnetic field, but who knew that our pet dog even noticed it, let alone cared about it? And that foxes, when they leap onto snow because they hear a sound in the subnivean realm just below the snow level for some rodent that's just below the surface, they too will generally jump up and leap in a northerly direction. So we're not, we humans, that is, are not very aware of magnetism, but other creatures are. Well, with the sun here, now everything we're seeing, the corona, the prominences, they're all magnetically driven. The prominences come from areas where the sun's magnetic field is generally 3,000 Gauss. By comparison, Earth's field around us is usually a third of a Gauss or a half a Gauss, and the sun's general surface, gaseous surface, is about 1 Gauss. Well, the stuff we're seeing today, that's 3,000 Gauss. So again, the magnetism is playing a big role in what we're looking at today.
Bob, I don't know about the rest of the dog owner viewers around, but I just want to get outside now and test this thing with my boy dog to see exactly whether or not he turns around and aligns himself to the Earth's magnetic pole. I want to see this over the next few days. I'm going to be doing an analysis, some research on that. So thank you very much for sharing that. I love that one.
Pleasure.
Bob, you are going to join us again next Monday for another pretty spectacular and incredibly rare event, once in 20 years. What's going on with two of the largest planets in the solar system at the moment that we're going to be taking a close look at next Monday?
We're going to see one of the most extraordinary showings of what astrologers and what the ancients for centuries and millennia have called the Great Conjunction. Of the 5 bright planets, they meet each other from time to time, as we all know, but the rarest meetings are between Jupiter and Saturn every 20 years, as you said. And because it's rarest, it's the only one called the Great Conjunction. And supposedly all sorts of earthly events are associated with it. None of them good, by the way. So the ancients always feared this. But what makes this one exceptional is the last time that we had this in the year 2000, and before that in 1980, and even before that in 1960, the planets didn't come that close together.
Yeah.
And the next one's coming up in October of 2040, and then again in 2060. The Jupiter and Saturn will also not be so close together that it'll be eye-catching. But this time, we're going to have them meet so closely that it's the finest great conjunction of our lives, and the finest actually in hundreds of years. And it won't be
I think
equal.
1623 or something was the last time they were this close together.
Yes, I think so. And it'll be October of this century, October of 2080, before we have this equaled or surpassed. So it's quite nice and a little challenging, because if we blow up through the Slooh telescopes, make them large enough to clearly see Jupiter or Saturn individually to see details, we'll also be blowing them up enough so that you won't see the other guy.
Bob, here's an interesting little thing, because you know the Slooh telescopes have got all of these different fields of view. Some of them can see a large area of sky, others are designed to see small areas of view. Now, already we're seeing in the telescopes with a large field of view, we are already seeing both planets in there. And the lovely
Excellent.
extra little bonus we get is we see the 4 Galilean moons, and we're also seeing the 2 largest moons of Saturn. But
Well,
they
excellent.
become, they are so close together on this great conjunction that they appear even within our telescopes with the smallest field of view, the Canary 4 Solar System telescope and the Chile 1 wide field telescope. They are so close that we're going to see the detail of both planets so close together. I think it's going to almost look artificial, Bob, because so many of us have never ever witnessed these 2 planets being
No,
apparently so
we haven't.
close
This
together.
is the best conjunction of our lives,
Mm,
bar none, the best. And I
mm,
think it's more spectacular than many of the traditional headline events. You know, we talk about transits of, let's say, Mercury and lunar eclipses. This is going to have all of them beat. This is one
yeah,
of the, and in terms of rarity, this is by far the rarest of all. It's rarer than a total solar eclipse.
yeah.
So I think this is a real don't miss event.
Absolutely. Now, just before I let you go, and just a last word on the Great Conjunction, wasn't this is quite well timed? Wasn't the Star of Bethlehem thought to maybe be a conjunction of 2 very bright objects like this? That was one of the theories, wasn't it?
Yeah, that's one of the explanations. But as I explained in a 6-page article in Discover magazine, and which got a lot of international favorable write-up, and eventually became a book written not by me but by somebody else. None of the Star of Bethlehem explanations that involve astronomy, such as was it a supernova, was it a
Mm,
comet, was it a conjunction? There was a
yeah,
interesting conjunction in the year 4 AD, and since the date of Jesus's birth is still debated, that could have been the explanation. None of them could have really explained it. None of them. And planetarium directors that have a show about this every year, usually called things like the Star of Wonder, and very popular. People go to the
yeah,
planetarium shows to look at these possible, what really the Star of Bethlehem could have been. And I guess we'll talk about this more because I don't want to just
we
keep
will.
hogging this up, but none of these could have actually explained it, which I think makes the mystery even more interesting.
Exactly. Bob, before we let you go, your final thoughts on today's South American total solar eclipse.
Well, it was amazing and mysterious that we had that coronal appearance
Mm,
that we saw. B, as always, what a wonderful thing. And I'm glad we got one of the 2 countries that Slooh was set up to view it from had clear enough skies for it.
yeah.
And so it always leaves you feeling that maybe all is right with the world, despite this very strange year that we've all
Yeah.
gone through for various reasons. This was a nice way to top it off. Actually, the only thing that can top this is the Great Conjunction next week. So looking forward to that.
Exactly. You know, these things bring us together and allow us to switch off from the some of the other things that are happening in 2020. Bob, thank you so much for joining us. As ever, we will see you next week, where we will have plenty to talk about for the
Okay,
Great Conjunction.
good.
Thank you very much for joining us today, Bob. Take
Thanks.
care.
My pleasure, my honor to be here. Thank you.
Wow, what a day! Now then, I'm hoping that very shortly we're going to welcome back for an on-site report Daniela Fernandez. If the studio can whisper in my ear if Daniela is going to be coming back on. That's great. She is going to be coming back on. Now, just to give you a little recap then on what we've been doing. This is one of the feeds that we've had from Parque Astronomica La Punta in Argentina. Now, they are outside of the Path of Totality, which is why we haven't seen totality in this feed. They've only had a partial solar eclipse. And at maximum, 73% of the sun was covered by the moon, which is pretty spectacular to watch. But as we've been explaining, 99.99% partial eclipse is nothing in comparison to totality. You have to witness totality with your own eyes to be able to believe what everybody else says about it. You know, I was talking to Dr. Kate Russo earlier, psychologist and eclipse chaser, and I couldn't help thinking when she was talking about people's first eclipse experiences or people's first totality experience, thinking back to mine. And I have to say, I was rather skeptical because all I'd heard was a bunch of people talking like I'm talking now about this remarkably profound experience of totality. And I was skeptical. I just didn't get it. And frankly, they couldn't explain it to me properly. So I was almost dismissive of it. And I thought, yeah, okay, well, I've seen plenty of partial solar eclipses. It's just going to be a little bit more of that. My word, it brought me to my knees and it brought me to tears. It's the most extraordinary human experience I have ever had in my life. And you'll hear a lot of people who have witnessed totality sometimes almost after a pause say, oh, other than when I got married, or oh, other than when my children were born. But to me, that always feels like a bit of an afterthought. For me, totality is just such a profound experience. You know, you cannot put it into words. Now, if you want to experience that, don't forget, we can pull it up on the screen. This is, I know it sounds cliche, but it is a once in a lifetime experience. And we're going to hear shortly just how much of a once in a lifetime experience this is. You can join us on Slooh's Antarctica Total Solar Eclipse expedition next year. It is a 20-day voyage of discovery and exploration down in Antarctica. We're going to go through the itinerary later with my special guest, Carl Shepard from Insider Expeditions, who's going to join us. And we may even have him on quite soon, actually, a little bit earlier than planned. But to witness this with a group of other people on a voyage, 20 days, we're going to see all manner of wildlife, but it's going to not culminate, but it's on December 4th, so it's kind of halfway through the whole expedition, to witness totality in Antarctica is going to be a pretty cool experience. So we'll share a little bit more detail in 15 minutes or so. But for now, I would like to welcome back Daniela Fernandez, resident astronomer from the Teaching Observatory of the Institute of Astrophysics, the Catholic University in Chile, where Slooh's observatory is located. Daniela, hi, how are you?
Hi, Paul. Super. Really, this was an amazing experience. We didn't have the corona, but it was amazing how the totality see here in the atmosphere. We're totally dark skies, and it was really, really, really amazing. I think you
Wow.
can see everything on the fisheye. The change of the brightness of these clouds that we have
Yeah.
here.
We were watching it, and I asked the studio to keep it on screen because I was talking to our psychologist, Dr. Kate Russo, and we suddenly saw the darkness descend, and we saw that some of you had gone outside, you know, to be
Yeah,
under that darkness, and then it went pitch black. And I was talking to Kate and saying, I bet you that still feels magical. And from what you're saying, it did, even though you couldn't see the sun. Can you
yeah.
explain how it felt?
It was different, Paul, because we were in the last year in the Vicuña here in Chile, and it was totally different this time. It was really magic. We were all outside with rain, and it was really dark outside. The temperature goes down, I don't know, a few degrees, something like that. We will see because we have a thermometer there monitoring this every
Okay.
moment. So I will share this information with Slooh, of course, late.
Oh, great. Great. Whenever we go on a Slooh expedition, we take a little box with lots of sensors in it so that we can measure, you know, things like the light levels and the temperature drop. So what did everybody else feel? Have many people reacted to how they felt, even though it's still for viewers, they're going to think we're mad to say that even though you couldn't see the sun, it was still this amazing experience. Did all of the people feel like that? Have you heard from any
Yes,
of them, spoken to them?
yes, they were really excited. They was really worried because we are here a lot of scientific, so they was like, "Oh, you will so sad because of you didn't see the corona." But everyone here was, "Oh my God, this is amazing! It's really, really, really dark." So it was an amazing experience, different than the last year, and we hope to go next year to Antarctica to do the live stream again.
Excellent. Well, we're going to be down there on our Slooh expedition, on board our vessel with 60 other lucky people. So that's going to be quite an adventure down there. So it's, I still find it amazing that it was such an extraordinary experience, even though you're sitting in the clouds. And you know, I don't know. You've experienced totality now. I mean, how can you measure the difference between the being and seeing the sun with totality versus today's event?
Oh wow! For the astronomical aspect, I really wanted to see the corona, of course,
Yeah,
but we didn't have the chance to see the sun today, so
yeah,
it was really okay. But I don't know, it was different. It was amazing. We will send you the video that I was doing on my social media
yeah.
because we are all of people we are here like outside in the rain seeing this phenomenon. It was really really amazing, Paul, really.
When we were watching in that view, the darkening seemed to happen very, very quickly, and then
Yeah,
after those couple of minutes, was it that quick in reality
yeah,
there?
yes, it was super super quick, just I don't know, a few seconds.
Oh,
Yeah, it was totally different than the year.
wow, amazing. So how long are you up there for? Are you packing up today and leaving today, or are you hanging around for another night?
Well, first we need to finish our live show because we have to talk now for inclusive astronomy and how the team experienced this amazing phenomena. But tomorrow we will rest and then go back to next day to Santiago and hope to enjoy Christmas and holidays.
Daniela, we will let you get off. I have to say thank you to you, thank you to Thomas, thank you for the whole university team. I know how hard you've worked for this, and I'm so pleased that the experience was still a little bit magical for you all there. Kate and I were sitting there thinking, oh no, they put so much work in, and then not to witness it. But you did witness totality, but just in a very different way. So I'm so pleased that you've done that. And thank you so much, for doing all the work to bring us these live feeds, which themselves were absolutely fascinating to watch.
Thank you, Paul. No, it was a really new experience, and let's see you next year here in Chile, in Antarctica, for this new adventure. But because
Exactly.
this will be an adventure, I think.
It will. The adventure of a
Yeah.
lifetime. Daniela, thank you so much indeed. You take care. I'll speak to you next week.
You're welcome. Bye bye.
Bye. Wow, that was Daniela Fernandez. Daniela, by the way, she is a resident astronomer from the Teaching Observatory at the Institute of Astrophysics at the Catholic University in Chile. But she also looks after Slooh's telescopes there, the telescopes that Slooh members control every night. And she does such a lot of outreach work, unpaid outreach work with school kids down in Chile, and bringing them science and math and astronomy in such an engaging way. She goes from tiny toddlers to, later school age teen school kids and stuff. So, it's we're very aligned in how we think about all of this. Daniela absolutely loves sharing her enthusiasm and love of astronomy. Now then, we are going to take a very short break, and we're going to show you our gift card, because if you've enjoyed the show and you've made it this far and you're not a Slooh member, then treat yourself to the gift of the universe. Come and join Slooh's community. Come and use the Slooh telescopes every single night. We do this kind of thing every day, not with a solar eclipse, but we are watching galaxies, nebulae, star clusters, planets, the moon, the sun live every single day from our observatories in the Canary Islands and Chile. If this is your kind of thing, you're going to love that. Or maybe you know somebody who loves it just as much as you do, and one of these gift cards for a year's membership of Slooh, you won't regret it. Now, after the break, I'm going to be joined by Carl Shepard from Insider Expeditions, and we are going to talk all about the Slooh Antarctica Total Solar Eclipse expedition and what you can expect in your 20-day polar odyssey. We're going to be right back after this short break. Bye for now. Hello and welcome back to Slooh's live coverage of the great South American total solar eclipse. I hope you've enjoyed the show so far. We've witnessed totality. We managed to get that totality shot. We've had some wonderful guests on. We've had Slooh astronomer Bob Berman. We've had Dr. Mike Shaw. We've had Dr. Kate Russo. But now I would like to welcome a very special guest, Carl Shepard, who is the founder of Insider Expeditions. Hello, Carl. Welcome to the show. How are you?
I'm great, Paul. Thank you so much. Great to be here on such a special day with you and all your fabulous guests and everyone tuning in for a bit of totality. Obviously, sad that we all couldn't be there in person, but thank you to you and Slooh for sharing with us.
Well, thank you very much. Now we can see the map behind you, which gives a kind of clue to what you get up to. And just over your right shoulder is where the Path of Totality was that we were watching today. But Carl, next year, December 4th, is the only total solar eclipse of the year. And that is only going to be visible from behind your shoulder. So where are we going on the Slooh Antarctica Solar Eclipse expedition with up to 60 lucky people joining us on that expedition?
Yeah, one thing, as you know, and so many know, once you have that moment of totality and you see it, you cannot wait for the next one because there's really sort of no moment like it, especially seeing it in person. I know I've been, all the ones I've seen, I'm already thinking ahead to where I'll be, and we're so happy and honored to partner with Slooh on this Antarctica expedition next year. We've been going to Antarctica for many years, and we've been doing solar eclipse trips for many years. But this is really a special expedition next year because it sort of combines both this just majestic landscapes of that part of the world, as well as with this celestial magic of totality. So the combination of those two things, years ago we started planning this expedition. That's one of the nice things about eclipses as a travel planner is we can plan our trips 10 years out. hundreds years
Yeah,
out.
it's like clockwork. Yeah.
And since we know where totality will be, but this one we really wanted to do in a very special way, choose a really beautiful modern ship that was very high tech, where we could bring all kinds of cool space toys on it with you and Slooh, so we could do all kinds of things like celestial navigation and have a lot of sort of wonder, not just at the places we're seeing, but up above throughout the 20 days. And we also, we chose an itinerary which is quite unique and includes South Georgia and the Falkland Islands, which Antarctica alone, of course, is a very remote, unique, often once in a lifetime place for people. And we've sort of combined it with some even seldom visited spots like the Falklands and South Georgia, which are amazing in their own right. Just this is the perfect time of year to do it. And the fact that we have the eclipse as well, it's really going to be a once in a lifetime 20 days and can't wait to do it with you.
It is. And the thing is with this eclipse, because of the eclipse path, which travels across the ocean in incredible speeds. And actually, let's stick here if we can, studio, because what we've got showing up on this map is the little bit of an eclipse path down at the right-hand side. And it's that little dotted line. The eclipse path, so everything that we've been talking about today, the moon's umbral shadow, the dark shadow, that's the bit where you see totality. It's traveling at tremendous speed. When it first hits the Earth, it's traveling across the surface of those oceans at 35,000 miles an hour. It's whizzing across this tiny, thin path, predominantly ocean. It does make, Carl, you'll be able to correct me if I'm wrong, but am I correct in using the term landfall when we're talking about the continent of Antarctica?
Yeah, the eclipse itself will travel or will travel both land and sea. And one of the nice things about being with a ship is that just like today, you saw in some parts of the path it's quite cloudy, and some parts of the path weather looks much better, and we'll be able to anticipate that and maneuver a little bit more with the ship. If you're on a single part and on land in Antarctica itself, that's probably the most unpredictable weather place to be, in the sense that weather changes there so fast, and it's very hard to move anywhere should the weather not be looking good. So the moment of totality we've chosen to see on the ship. And the other thing that's so cool about the South Weddell Sea in this area is that there will be sea ice around us, there'll be glaciers around us. It'll just be in the early part of the summer where the ice has been melting, but we'll see plenty of ice and glaciers, and obviously we'll be in a world-class, Polar 6 vessel that can handle those conditions. But I think that the shadows and the way the light, will play in the landscape around us is going to be really, really quite special.
It will. I mean, this is. It's difficult not to sound cliched when we're trying to describe this expedition, because I believe this is going to, excuse the pun, but it's going to eclipse all of my previous eclipse experiences. The lighting down there, just being on such a modern ship as this, is going to be an experience. But everywhere I've been for our total solar eclipses, we've kind of picked our position, and where you are, you can't up and leave. If you've got some clouds, you've got to kind of stick exactly where you are. But this ship can put a bit of welly on, as we say in the UK. In other words, it can go pretty darn fast, so that we can literally eclipse chase. If there are any clouds in one location, then we can get to a clear path, hopefully a clear path. So anyway, it's a very difficult eclipse to see, which kind of makes it all the more special for me, because we are going to be among a very small group of people who are able to witness this firsthand. Of course, because we're Slooh, we're going to be broadcasting live as well. Now, there are some good old technical challenges in there, being able to, because I don't know if many viewers know this, but there aren't many cable providers down in Antarctica. So we're going to be satellite linking in all sorts of things for our eclipse expedition down there. But let's go through the itinerary. So you were talking first of all that this was it's going to be a perfect time of year. It's going to be cold. We might have some sun. We should have some sunny days, but we may even get a little bit of snow. but that also means that there aren't going to be many other ships down there. A lot of the normal kind of touristy Antarctic ships aren't going to be down there, are they, Carl?
I mean, I'll be surprised if we see another ship on our adventure. That there certainly will be some others, but that's one of the most amazing things just about Antarctica. It is so remote. It is the opposite of going into Walt Disney World in terms of crowds. Everywhere we go will just be us. We have room for about 60 people on this Slooh expedition, and of course we'll be doing workshops and all kinds of cool things while we're at sea, and amazing land visits while we're sort of in port, which will mean taking small zodiacs and landing at these sites where we can do that on these different islands. So no, but it'll be quite remote, and we really won't see a lot of other humans. What we will see is a lot of other wildlife. I think a lot of my friends and who love chasing these eclipses tend to be people who also really appreciate just the wonders of the natural world in general. And one of the most exciting things about an expedition like this is the sort of the birds that you see nowhere else in the world. The animals and wildlife in the water and on land are quite extraordinary. So for appreciators of the natural world, it does not get better than this.
Yeah, and I think we've got a bunch of expert talks as well, and some of those are going to be on climate change. But we're going to when we set off on the expedition, 20 days, we're leaving from, isn't it the most southerly city or port in the world?
That's right. Ushuaia, Argentina. Argentina, of course.
Here we go. Yeah.
I've had a nice had the fair weather today, and we'll be down at the very tip of Argentina at the end of next year. And it's a very it's the very end of Patagonia. It's a very cool place in its own right, just to explore. Ushuaia, it is it loves to call itself the southernmost city on the planet. I think that is true. Although when we are in Antarctica, there will be a couple research stations we'll have the chance to visit. These are, of course, like 10 or 12 people, sometimes 40 people at a base. So not quite a city, but in terms of cities, Ushuaia is the southernmost. And then we set sail from there, toward the Drake Passage, which of course is a very famous, sort of place of lore in general, and a sort of a rite of passage for anyone going down to Antarctica. The seas there can be crystal clear. The seas can have rough days. Luckily, we're on one of the newest ships in the world, so I'm not worried about that. But that itself is an amazing crossing, and that's when you pass the Antarctic convergence, which is sort of the natural boundary where the cold waters, flowing north with the sub-Antarctic seas, and the warmer waters coming in from the sides, really converge and create this opportunity for all kinds of fish and birds and wildlife that you start seeing there, and you don't see them anywhere else. And from there, we head down to Antarctica, where we'll have several days to visit some research stations, see plenty of penguins, see lots of wildlife, and at that point we're just getting started. I mean, haven't even gotten to the eclipse yet, and I think one of the things about this expedition is that we really wanted to plan it in a way where it was, every moment of it was sort of, if you're going to make the effort to go all the way down there, we wanted to sort of include everything that was possible.
Absolutely, and I think what it's going to give us all, and so many Slooh members are, have this same fascination with the natural world as well as astronomy. So I think it's going to be a huge group of very like-minded people. We're coming at all of these subjects from slightly different directions, but we're going to be able to immerse ourselves in these pleasures, this curiosity, and I think that is probably the one shared trait that everybody on this trip is going to have. They're curious. They're curious about our planet. They're curious about wildlife. They're curious about space and these kind of phenomena that we're going to see. What do you think are going to be, other than obviously witnessing totality in that kind of environment, Carl? What are some of the highlights that people joining us on the expedition have got to look forward to?
Sure. Yeah. I think, aside from the landscapes and the eclipse, which I'll go into a bit more in a second, I think you're absolutely right that the people and the community on board will just be so cool because, much
Mm,
like this morning, there's a lot going on in the world right now, a lot
yeah.
to be worried about, distracted with, focused on. Not to mention it's a Monday morning where people have plenty of work in their daily routines to be focused on, and you're able to attract thousands and really millions of people in the world who, given all of that, still tune in for a Monday morning to look at the celestial bodies and the awesomeness of an eclipse.
Mm,
Those are the types of people I love hanging out with.
yeah.
People who really care about this stuff. And I think that the chance to travel, I mean, we've been doing group travel now for 15 years, and all of the amazing places aside, the best thing is always the people you're traveling with and learning from them and their
Mm,
experiences. When you're on a ship, it's a very special environment. I've probably spent about a year of my life on ships at sea in different group travel experiences, and it's amazing because not only do you have the ocean and all the amazing places you're seeing, but you really have this community of people who you're socializing with, you're learning from, you're doing presentations with, you have participant
mm,
led activities. And that's the part that stays with you far beyond the 20 days, and those friendships, and to be surrounded with people who really care about the cosmos, care about the natural world, care about climate change, which we're going to talk a lot about and see a lot
yeah.
down there as well. And and love learning about these issues. It'll be really special to travel with them. So first and foremost, I would say the people. Certainly that the landscapes we'll see both from the animals there and the birds. And if you're a birder, there's
Yeah.
this is such a unique space. There are tons of birds whose names I can't even pronounce, who you only see down there. So more every time, there's more species of penguins I thought would be possible,
Mm,
and then you combine sort of the history, and for the last, it's only been really a
yeah.
few hundred years when humans have been exploring Antarctica. There's even up to today, there's still such a small percentage of humans ever who ever even get to visit. I mean, we're so lucky to have the chance to make it down there. It's really,
Carl,
really rare,
uh,
rare thing. Yeah.
aren't we stopping off at an area associated to Shackleton?
Exactly, and beyond Antarctica, we're going to see South Georgia and the Falkland Islands, which are very famous with these various explorers. South Georgia is of course the last place Shackleton was. That's where it's his sort of final resting place there. So we'll speak a lot about
Mm,
Shackleton in South Georgia and be able to see his gravesite there and sort of learn about his adventures, both good and bad, and many. He's certainly one of the most famous, but there are many of these interesting expeditions that will sort of be joining, a long legacy of
yeah.
curious explorers down there that really have done some insane, crazy things to better the understanding and knowledge of humanity. I
Yeah.
will say, well, we're in that same spirit, but in a very, very safe way.
Exactly.
Yeah, our ship is honestly the newest Polar 6 class ship down there. It's a world class vessel, scientifically speaking. It has really amazing capabilities, and it also is just a great place for seminars, workshops,
Yeah.
socializing, and it's built to exceed all the current sustainability standards as well.
Yeah, I mean, it's I have to say, as a child, we spoke about this before, but as a kid, I was captivated by the stories of the early explorers, whether or not they were going around the world in sailing ships or whether or not they were exploring Antarctica. And in fact, just by chance, this evening, I noticed on TV here in the UK, there's that wonderful film, Scott of the Antarctic. So I know what I'm doing to chill after this eclipse. I'm going to be watching watching that to get me in the mood for next year. But you mentioned about the climate. It's not only a perfect time for us, cold, but not too cold, sunny, and also because of the time of year, all of that wildlife is kind of coming back to life almost. And I'm really looking forward to seeing a lot of species that I've never seen before. But you've been in your career, Carl, you've been over 100 countries, but a lot of this is going to be new to you as well. Are there specific places on this expedition that you're particularly looking forward to seeing?
Yeah, thanks. I mean, I feel very very lucky to be in the travel world where that's sort of aside from this year, normally something we're doing quite a lot. And while I've been to Antarctica, I've certainly never been to a lot of these places on this particular expedition. South Georgia and Port Stanley and the Falkland Islands are really places that very few people
Mm,
ever get to see. They're perfect to see on this expedition because of the way the eclipse is. You sort of will have that moment of totality really between South Georgia and Antarctica, and that whole area with the ice as it's is sort of heading into the summer. Both the wildlife and the shapes there of the glaciers will just be spectacular in late November and early December. So yeah, I'm as always, I'm so personally looking forward to not just places where I've never been, and learning about things that I'm sure will inspire and awe, but sharing this in a way with like-minded people who really care about our magic and beautiful natural world that we live in. So
we've got
I'm
a
couldn't be more excited for it. Yeah.
We've got a bundle of experts lined up to keep us all entertained. I'm going to be hopefully dealing with a lot of the star watching, which is going to be pretty spectacular down there in the Southern Hemisphere. I'm really looking forward to some of those dark skies. And of course, because it's centered around, as we've learned today, a total solar eclipse, it means it's going to be new moon around the middle of our expedition, which means we're going to have incredibly dark skies. I'm looking forward to some nighttime photography to hopefully with a very still, calm sea to maybe get some reflections of the southern Milky Way down there. But so, what other experts have we got joining us on the expeditions, Carla? And what kind of topics are we going to be dealing with? We've mentioned climate change, but presumably we've got quite a few naturalists there as well.
Absolutely. We'll have honestly a full team of guides and expert talks leading things without certainly about the animals, the flora and fauna that we'll be seeing down there. Certainly about climate
Mm,
and the changes that are happening in Antarctica. Certainly about the
mm,
regulations and laws that govern this unique part of the world, which is really
yeah,
controlled by no one country. I mean, it's quite special in that sense as well that the governance of Antarctica, who gets to say what happens. It's a very regulated place,
yeah,
thank goodness, but quite
yeah.
interesting. It's a very UN style approach. It really belongs to all of humanity and not one country. So we talked about how that happens and the laws down there. And certainly a lot about celestial navigation, photography,
Cool.
all the things you can imagine around any total solar eclipse experience and the best ways to do it and things to think about since we'll be at sea as well. And yeah, so I think we'll have no shortage of presentations and topics to think about for those 2.5 weeks.
Yeah, it's going to be a remarkable experience. You can't believe how much I'm looking forward to it. And it's like you said earlier. Actually, one of the things I'm most looking forward to is the company. To just be immersed in a whole bunch of curious people who get kicks out of learning more about the natural world or those explorers that we're going in the footsteps of, let alone this phenomenal celestial event that we're going to witness in the middle of it. So, Carl, you mentioned birds earlier. Where can viewers find out more? Because there's something to do with some early bird stuff, isn't there?
That's right. We actually, in honor of the eclipse today, we just launched early bird registration today.
Great.
So if you're watching, in addition to all the fabulous birds down in this part of the world, we're also celebrating the early birds, and you can get in today with special pricing. Registration just opened today for Totality, and it's insiderexpeditions.com/Slooh, insiderexpeditions.com/Slooh, and there you can find all the details about the expedition, the dates, where we'll be going, and how to register and save one of the 60 spots that we have.
Yeah. Wow, I'm so excited. What I don't think I've ever ended a total eclipse show being quite so excited for the next one. So this is a total new experience for me. Carl, is there anything else that we've missed out that we should be telling viewers about the Slooh Antarctic Total Solar Eclipse expedition?
No, I think look forward to meeting all of you to join us there. There's going to be, I think that moment of totality, those 2 minutes will be magical, but it's really going to be 20 days of magic.
Yeah.
So looking up, looking around, and looking and sharing with all of our celestial curious travelers on board. So really looking forward to it. And yeah, as you said, the moment the one eclipse ends, I'm always looking forward to the next one. So this next one is going to be quite special.
Well, Carl, it's been great working with you so far. We're going to be working throughout 2020. We're going to make this the experience of a lifetime for not only ourselves, but also for 60 other rather fortunate people. So thank you very much, Carl, for joining us. I hope you've enjoyed the rest of today's eclipse, and we'll speak to you soon.
All right. Thank you, guys. Looking forward.
Take care, Carl. Wow, what a day. And we are still seeing the partial solar eclipse from Parque Astronomica La Punta in Argentina. So what we are seeing here is the moon shadow very nearly leaving the sun. But what I would, we're going to take a look at the replay in a minute, but what I would like to do is let's just take a step back all the way to the beginning. Let's see our eclipse path diagrams. Maybe we've got the animation or one of the maps that we've got, because that'll kind of put into context what we've been doing really over the last 3 hours. So the studio will pull those up, but what a fabulous collection of guests we've had today. So here we go. Maybe we can go into one of the ones that is pulled out a little bit wider than that, because they were quite zoomed in to Argentina and Chile. So there we are, South America. We can see it centered there. The moon's shadow, which is kind of circular. It's actually elliptical when it hits the spherical Earth surface. First touchdown just at the left-hand side. You see that big yellow kind of odd shape? The center of that, that's where the moon's penumbral shadow first touched the Earth's surface. Now, if you were in that green box at that time, over on the left, you would have seen the moon take its first chunk out of the corner of the sun. If you were in that little white zone there in the Pacific Ocean, you would have witnessed totality right at the beginning. But the moon shadow was whizzing across this entire field. So if you can imagine, if you were anywhere in that green line zone, you were going to see a partial solar eclipse, just as we have done in the Argentinian feed there. If you're in that very narrow, that 56-mile wide path, if you were fortunate enough to be within that zone, then you would have seen totality. Look how narrow it is. And there we've got our site at the Villarrica volcano, the most active volcano in Chile. And our team from the Catholic University there were a little bit weathered out. They had special permission. They've been working on months for this for us to bring us these live feeds. And even though they were clouded out in Chile, they still said it was a magical experience when the moon's umbral shadow, the dark umbral shadow, plunged them into total darkness for 2 minutes. And then it came out again. Now then, let's hop back to that Argentina live feed of the partial phase, because they didn't witness totality at this particular location, we were lucky enough to see totality from another region in Argentina. So these guys are located north of that path of totality. So they only got to see 73% of the sun's surface covered by the moon. And what we have seen earlier is there is no comparison. If you've ever witnessed a partial solar eclipse and you kind of gone, nah, you know, it's okay, don't see what the fuss is about. When people have been talking to you about totality and the experience of totality, there is no comparison whatsoever. I cannot, and hopefully you listened to our guests earlier, there is literally no comparison between a partial solar eclipse, even when it's 99.99% partial, to experiencing totality. Now is a good time to go back to our replay, because if we watch this from beginning to end, there we go, just as we're entering totality, we can see, even through the thin clouds that we've got, we can see that corona, the sun's crown that Bob was talking about. And when you see this without the clouds there, it's so tenuous. It looks like the wispiest material you've ever seen. Now look at the top left-hand corner, because that's where the sun is going to emerge from behind the moon. Now, when we see this, you're going to see the diamond ring effect. And what we were saying with Bob is, whenever I've witnessed this, it's been the moment where people whoop with joy, because it is just such a spectacular sight. But it's not that profound. There's the diamond ring coming now. All right, bang. And when you see this in person, it just explodes. Now, don't forget, they took their filter off. They've now put their filter back on to this camera. This is a 99.99% total eclipse, partial eclipse that we're looking at now. There's no comparison between this and that short moment of totality. And I'll tell you, you know, I can't describe it to you. We've had Dr. Kate Russo, who's been eclipse chasing for decades, who's been studying as a psychologist, the impact, the profound emotional impact that witnessing totality has on people. She can't explain it. And kind of, we don't want it explained, because once you've experienced it, you kind of, you want to analyze it, but you don't want an answer, because it's just so deep, the emotional response to this, so deep. I want everybody on earth to witness this at least once in their life. Now, I have said this one before. At some point, all of the total solar eclipses so far that I have witnessed, I haven't really witnessed them, because I've been looking into a camera quite often with the eclipse happening behind me, so that the camera's got me in shot and the eclipse. So I am absolutely determined, certainly not for next year, because we're going to be broadcasting the Antarctica total solar eclipse to the world, just as we normally do. We were the first people to do it. We were the pioneers of bringing live celestial events to the general public online. But not next year's one, because we're going to be broadcasting that live. But I'm going to pick a total solar eclipse at some point over the next few years, and I'm not going to take even my mobile phone with me. I don't want the merest semblance of technology with me. I want to just probably sit there with my loved ones watching that moment of totality in total isolation and possible silence, other than my dripping eyes and tears hitting the floor. So here we are. We've got these last moments of partial eclipse. Now, what I always find interesting on this little phase of an eclipse, it's like the beginning. When does it end? Because it's really a little bit more difficult than you think to spot both the very beginning of the eclipse and the very end. Now, we can see it quite obviously there. We can see that there's a little chunk taken out of the sun. But as we watch over the next couple of minutes, who's going to be the last person who thinks they can still see that little chunk of the moon leaving the sun? So it's not usually me, by the way. I don't normally win this competition at all. So we've got 2 solar eclipses next year, one of which is called an annular eclipse. in the first half of the year, and that's often called a ring of fire eclipse, and they're quite spectacular to watch. But you'd still see a view like this, but with a big black circle of the moon, obscuring the center of the sun. But you still see this ring of fire around it. It's pretty spectacular. But next year, 2021, has only a single total solar eclipse, and that occurs on December 4th. And the only place you can see it is in Antarctica. And we're going to be there. Hopefully, some of you guys can join us on our expedition. But if you can't, then you can watch online. You would not believe the technical challenge. We thought going to the heart of Africa was difficult to broadcast to the world. We did it. We did it actually with the help of some Spanish Army guys and a whole team from the Institute of Astrophysics of the Canary Islands helping us. But we were satellite broadcasting. We had this military guy whose only job in the military was to sort out their communications when they were in the middle of nowhere. And we were broadcasting over satellite for that. It's really difficult to interview people when you've got that kind of time delay. But we've got that. So we've got that as a challenge down in Antarctica. But of course, we're also going to be, as you heard from Carl Shepard from Insider Expeditions, we're going to be, I can still see a bite out of the sun. Can you? We are going to be on a ship. Now, imagine doing this. We've got a telescope here, and we're going to be on a ship. The ship's going to be moving very slightly. Well, I hope very slightly, because if it's too much, then it's going to be even more difficult. But we're going to have a whole bundle of cameras and telescopes set up. We're going to be doing live stargazing each and every night as well. One of the things I love about going on a new expedition is it gives me an excuse to buy some new technology and camera. Can you still see it? Can you still see it? We are at the very moment. This is the culmination now, this little moment of over 10 years of Slooh covering eclipses and live celestial events. I think I can still see just the last little nibble there. I can see it. I can still see it. We were the first people to do this. We were the first people to bring telescopes online. Slooh members use, control, and watch the live streams of galaxies, of nebulae, of star clusters, of planets, the moon, and the sun every single day. And if you're into this kind of stuff, you don't have to be sciencey or nerdy to enjoy it. We've got such a range of characters and interests. Can you still see it? In the Slooh community, global community of members. I don't think I can see it. Is that officially the end of our eclipse? Can anyone else see it? I don't know. I can't see it now. I think that's it. I cannot see the slightest little dimple taken out of the sun by the moon. Our moon is now off on its journey around Earth. It's not going to align again between the Earth and the sun for another few months yet. And we're not going to see it cover the sun like we did today until December 4th, 2021. Now then, what a way to forget some of the woes of 2020. It's been a difficult year for so many people. The Slooh team have been very fortunate. We normally work from home. We're around the world. We're separated by thousands of miles. But it's a great team here at Slooh. Thank you to everybody involved at Slooh, both in the studio and all our engineering team. And we've had our operations manager, Andrew Dumbleton, sorting out some of the feeds for us to feed into the Slooh camera. So hopefully everybody was snapping images of the eclipse, because I'm rather looking forward to seeing some of your eclipse posters later. We got to see Totality, our poor partners down at the Catholic University in Chile. They were weathered out, just as everybody in the Path of Totality in Chile was weathered out. It was only across the mountain range in Argentina that the weather cleared to get a clear view of our sun, get engulfed by the moon. So we've had some great guests today, haven't we? We've had Slooh astronomer and astronomy author Bob Berman. Do yourself a favor, buy one of Bob's books or read his Strange Universe column in Astronomy magazine. We had Dr. Mike Shaw, Mike is just such a nightscape astrophotography expert. He's also written some books, so there's some great ideas here for gifts. Of course, the main one is up on the screen at the moment, the gift of the universe. What more can you give somebody other than the gift of the universe? Give somebody a Slooh membership for a year to control the telescopes and stuff. We also had psychologist and eclipse chaser Dr. Kate Russo. Poor Kate was due to be in Argentina, where we were seeing that live feed from. But because of travel restrictions, she had to stay in Australia, but she was due to go to Argentina. So, Kate, we are going to see you down on the expeditions in Antarctica next year. So that's going to be fun. We had a resident astronomer at Slooh's Observatory at the Catholic University Observatory in Chile, Daniela Fernandez, giving us those on-site reports. I am so glad for them that it was still an amazing experience, even though they were clouded out. They were still plunged into darkness, so they still had a great experience. And of course, we had Carl Shepard from Insider Expeditions join us as well to talk more. You need to go to that webpage that we told you about, download the brochure. It is going to be a phenomenal trip. All right. I know that I'm never going to experience anything like this in my lifetime, and I would love to share it with some of you. Thanks to our feed partners. Of course, we had the main feed that we had coming through was the Parque Astronomica La Punta from Argentina. That was Ronnie Tapia who brought us that. So thank you very much. Canal 10 TV in Argentina. We had quite a few of their little bits of feed as well. Plus all of the other feed partners that we featured today. Thank you very much, everybody. Let's take one final look at totality. There you go. I just dumped that on to the studio to see if they are still with it, awake and keeping me company while they pull that up. Coming up at Slooh, we're not like the rest of them. We don't just do one of these a year. We do these every week, every month, throughout the year. We've been doing it for over 10 years. And next Monday, we've got just a short week to wait for two phenomenal events. We've got the December solstice, the still sun, when the sun appears to be static in the sky. It's at its most southerly point in the night sky. So that is on Monday 21st, 9:30 UTC. That's 5:30 a.m. Eastern time. It's well timed for all of our members over in India. So looking forward to them joining. We're going to have live views. Here's the replay of totality that we had a little earlier. I'll let you enjoy that while I'm explaining this. We're going to have live views next Monday of from the Slooh Solar Telescope, which members watch every weekday. Amazing detail on the sun, and you can snap in images of that. But at the end of that little show, it's only going to be a little show, we've got actor and yogi Caroline Kinsolving coming on, and she's going to tell us a little bit about the sun and how it's related to yoga, and we're going to do a little yoga session. That'll be fun, won't it? And then later on that night, a few hours after, well, quite a few hours afterwards, actually, 2 p.m. Eastern, which is 1900 UTC, we've got the Great Conjunction. Now, I spoke to Bob earlier. You can rewatch this show if you want to watch that segment again about the Great Conjunction. Sometimes this is being lauded up as the Christmas star. That's Monday, December 21st, 1900 UTC, 2 p.m. Eastern time. But Slooh members are already watching this Great Conjunction of the two gas giant planets, Jupiter and Saturn, as they get closer and closer together in the night sky. If you've got a clear night anytime this week, go outside into your own backyard shortly after dark, and it has to be shortly after dark because they do set. They're going to be low down in the southwest, and you'll see these two giant planets close together. They come so close together, though, next Monday, that we're going to be able to see them in Slooh's Canary Islands 4 Solar System Telescope. These two planets so close together, it is going to be a remarkable sight to watch. I'm really looking forward to that. Only happens once every 20 years, and this one is as close as these two planets have been since 1623. I've said that several times. I really, really hope I've got that date right. Anyway, listen, thank you so much for all of you for joining us for this spectacular South American total solar eclipse of the sun. What a few hours. Great to spend it with all of you. I hope you've enjoyed our coverage. Thank you very much. Until next week. Bye for now.